Animatalization. Good evening, everyone. Hello, where are my beautiful little ones? Hello, hey there, new uniform. Yay, good evening, everyone. Marathon, right? And we are going a YouTube live over there. That's why, okay? Hello, good evening, Khadija, Evelyn, Srinanda. You're in black. Wow. I like this too. That is in blue, right? Yeah, I like that. Okay, fine. Are you ready for another marathon session? Are you guys ready for that? What? What? About better? Yeah. Why are you in black? This is our last chemistry class, right? And even we are running a marathon over here. So if I get sweat, it will be better black. It won't appearing in the black color, right? Okay, I didn't knew. Alright. So, are you guys ready? No response at all. Are you guys ready? Louder. No, not ready. Yes, Evelyn, it's our last chemistry class, okay? Not the entire class, it's the chemistry class, the marathon. We are ending the chapters, right? Okay. So, quickly give me a fist bump if you are all ready for the class. If you are all ready to run along with me, just give me a fist bump. I got it. Alright. Let's run like anything. Okay, yeah. Let's run like anything.
And they're emotional too.
Emotional.
Because they're gonna miss you.
Okay. Evelyn, we can keep in touch in Instagram. We have Instagram, right? We can keep in touch. No worries at all. Okay. So, we will keep this all emotional thing at the end, okay? So, you have to complete 2 chapters within 2 hours. Okay, it's gonna blow your mind. Okay, which is the first chapter? Ephraim. As expected, it's Mahima ma'am, okay? Alright, I'll miss my little child, So you guys are considering me as a child, even I'm 25, guys, I'm 25. Alright, so the chapters that we are going to discuss today is nothing but metals and non-metals, the the third chapter, and the last chapter, carbon atoms compound, the biggest chapter within 2 hours. Can you imagine? Yes, you have to, okay? So you have to run like anything, okay? Run like if there is no tomorrow, okay? Alright, you act like a kid. No, I have to act a bit serious, right? Because we are running a marathon. And here we go, run like the wind. Okay. Alright. So, into the first chapter. Here we go. Metals and non-metals, okay? We are going to discuss all the possible questions which will come from this chapter, metals and non-metals. Okay, so let's begin then. What is there to study in this chapter? Okay, here we go. Physical properties, chemical properties, reaction of metals and non-metals, okay? Wait a second. Okay, so can I get a break? Can I get a break? Ta-da! I'm back, okay? Alright, so what are the important topics that we have to learn from this chapter? Physical properties of metals and non-metals. You know the exceptional case as well, right? So you have to remember the physical properties, and coming into the chemical properties, reaction with oxygen, reaction with water, reaction with acids. Okay, you have to remember those things. And reaction of metals and non-metals. Okay, reaction of metals and non-metals, where you have to study about the ionic compounds and their properties, and okay, and you have to also remember how to draw the electron dot structure for them. And finally, occurrence of metal, how to extract the metals. Okay, we have three types, right? Least reactive, moderately reactive, and highly reactive metals. You should know how to extract them from their ores. Okay, so if you study this much, ta-da, done. Okay, so let's discuss some important questions from this chapter. Okay, easy. Abdul is like easy peasy lemon squeezy, ma'am. Okay, here we go with the first question. Ta-da. Where is it? Sodium kept immersed in kerosene oil because, and I want the quick answer in the comment box. We are running a marathon. We are not walking. Marathon. So answers should be there in the comment box. Okay. And the people who is watching on YouTube, you can answer as well as the chat box. Okay. So what's the reason? Sodium is the most reactive metal. That's the correct answer, right? Sodium is the most reactive metal. When we keep the sodium in the open air, it will catch fire. Okay, it will catch fire. In order to avoid all the accidents caused by the sodium, we always keep them immersed in kerosene, not in water. What if we keep in water? Explosion, a big explosion, so perfect. No, it is kept in kerosene oil because it's the most reactive element. Okay, and it's like YouTube also, ma'am, do you want me to comment in the classroom as well as in the YouTube? No need, honey. Okay, so here we go. Which of the following reactions shows that the given oxide is amphoteric in nature? What do you mean by amphoteric oxides? What do you mean by amphoteric oxide? The metal oxide which will react with acid as well as base to form salt and water, they are called the amphoteric oxides. And the given option, zinc oxide. Zinc oxide is an amphoteric oxide, and aluminum oxide as well as an amphoteric oxide. It can react with acid. Let me change the color of the pen. It can react with acid. It can react with a base as well. So look into the option D. B and C together can be called as an amphoteric nature of the zinc oxide. Okay. I said, what happened to the blue uniform, ma'am? So I just washed it. After a long time, I just washed it. Okay. Alright. Here we go. Which one of the following structure correctly depicts the compound CaCl2? So you have to remember this, okay? Calcium will donate 2 electrons to each chlorine atom. So 2 chlorine atoms accept 2 electrons from the calcium. Okay, and tell me the answer. It's the option C. Very good. Mukta is like a blast in the comment box. Okay, so it is Ca2 plus and chlorine with 8 electron. 1 is from the calcium. Okay, and the minus and 2. Do not ever forget to write the 2 at the bottom because we have 2 chlorine atoms. So it is CaCl2, right? We have 2 chlorine atoms, so put 2 at the bottom of chlorine. Okay, we have 2 chlorine atoms. I hope everyone is catching up with me, right? If you have any doubt, just stop me at any point. Okay. Alright, so someone is like, see with the question mark. Are you going to put question mark in the exam paper or the answer script? Okay. So the process in which the carbonate ore is heated strongly in the limited supply of air to convert it into metal oxide. That process is called as what? Carbonate into its oxide. The process in the limited supply of air or in the absence of air, carbonate is calcination. You have to remember that, okay? Calcination is the right answer. And sulfide ore, what about the sulfide ore? Sulfide ore can be converted into its oxide in the presence of air, and that is called as roasting. Okay, you have to remember the terms roasting and the calcination. Okay, and which of the following metal will not give H2 with H2O? Okay, we have the water. So, well, let's talk about the first one, sodium. Sodium will vigorously react with water to produce salt and, sodium hydroxide as well as the hydroxide and the hydrogen gas. Okay, sodium will produce a hydrogen gas, and magnesium will not react to the cold water, but it will react with the hot water to produce hydrogen gas. Definitely, magnesium hydroxide and the hydrogen gas will be produced. I'm talking about the zinc and water. Okay, what about zinc? Zinc will not react with the hot water, but it will react with the steam. Okay, zinc can react with the steam water vapor, and it can also form the hydrogen gas. And what about copper? Copper is the least reactive metal. It's less reactive, right? So it won't react with the water. Copper won't react with the water, so there is no hydrogen gas. So option D is the right answer. I hope everyone is getting the right answers, right? Okay, next question. The most abundant metal in the earth crust. Which is the most abundant metal in the earth crust? It's aluminium. Okay, aluminium is the most abundant metal that we can find in the earth crust. Okay, it's option B, aluminium. Okay. And the next one, galvanization is a method of protecting iron from rusting. Okay, so we have to protect the iron from rusting, and the process is called as galvanization. It is a coating a layer of a metal above the surface of iron or steel. That's galvanization, which is a metal. Of course, it is zinc. Coating a layer of zinc will help to prevent the rusting of iron, and the process is called as galvanization. Okay, important one. Metal M of moderate reactivity is present as its sulfide X. On heating in air, X converts into its oxide Y and a gas evolved. On heating Y and X together, the metal M is produced. X and Y respectively are. Okay, so we have copper sulfide. Let's write out. Let's take the copper sulfide first. Okay, Cu2S. You have to remember this equation. Okay, Cu2S. It's a sulfide, so we have to heat it in the presence of oxygen. Roasting. What will be forming? Cu2O, cuprous oxide and the sulfur dioxide. In order to balance, put 2 over here, 2 and the sulfur and 6 oxygen. Okay, no, 3. Okay, then it will be 3 2 6. Okay, 3 oxygen. This is the reaction. Okay, so cuprous sulfide and the cuprous oxide. Okay, cuprous sulfide and the cuprous oxide. You can follow the reaction, right? Can you continue this? Cu2O will again combine with the leftover cuprous sulfide and forms copper and the sulfur dioxide. It forms the sulfur dioxide. So, in order to balance it, put 2 over here and the 6 copper. Okay, done. You have to remember this equation, okay? Video is lagging. So can you check the internet connection, Melina? Okay. So these 2 reactions are really important. You have to study this, okay? And the balancing as well. It's clear for me. Okay. Okay. Voice is lagging for some, right? Okay. So this thing, copper extracting from the sulfur ore, it's really important. And the balancing as well. If you just write the unbalanced chemical equation, you will lose the marks, okay? Okay, next question. Okay, so option A is the right answer. First one is X is cuprous sulfide and the Y is cuprous oxide. Am I clear to everyone now? Is the voice audible? Is it perfect? Okay. Now, did you get the answer for this question? Yes, right? Okay. Next question. Which of the following is a characteristic of metals? They have 1 to 3 valence electrons. They have 4 to 8 valence electrons. They are brittle. They are capable to form anions easily. These 3 are the properties of non-metals, and the answer is they have 3 valence electrons and they are forming cations, right? They usually form the cations, not the anions. Okay, so option A is the right answer. Okay, got it? Are you guys running along with me or resting somewhere? No, right? If you rest, you will rust. Okay, so just run along with me. Okay, that is good, right?
Yeah, that's good.
That is good. If you rest, you will rust. Oh wow. How could I? Yeah, that is good. Which of the following non-metals is a good conductor of electricity? Okay, which of the following non-metals is a Non-metal is a good conductor of electricity. It's graphite, right? Graphite, exceptional case. Usually non-metals are not a good conductor of electricity, but graphite is a good conductor of electricity due to the presence of a free electron. Okay, now that's the correct answer. Now into the next question. Test tube ABC contains zinc sulfate. Okay, we have the zinc sulfate, silver nitrate and the iron sulfate in the 3 test tubes. Okay, and copper piece added to each test tube, and the blue color will appear in the case of what? Blue color will appear. Blue color will appear in the case of which test tube? Okay, zinc sulfate and copper. No, copper is less reactive than zinc, so no reaction. Coming into the next one, copper and AgNO3 will give you what? Copper nitrate and silver. Okay, copper nitrate and the silver, not to balance, put 2 and 2 over here. And the thing is, copper nitrate is blue in color and copper is more reactive than silver, and copper nitrate is blue in color. Okay, it is blue in color. Okay, you might be confusing about the colors, and at the end of the chapter I will show you the colors of the compounds. You can learn it. Okay, at the end of the chapter I'll give you a table, okay, so that you can remember the color of the compounds. Okay, you won't be getting confused with that. Okay, so which will be the right answer? It is the test tube B. Okay, test tube B is the right answer. Okay, that is option B. Test tube B, option B. Okay, got it? You have to respond to me in the comment box. You know that, right? Otherwise, it will be a one-way talking. I won't understand whether you are getting the concepts or not. So, yes, Anaga. Okay, set. Now, in the following practical set, which of the following gas is emitted? We have a metal reacting with the steam. Metal plus steam. Metal plus water, H2O. Metal plus H2O will give you which gas? Which gas? Hydrogen gas as usual. Okay, hydrogen gas will be produced, right? Any metal with the water or acid, hydrogen gas will be produced, which will pop. If we bring a burning matchstick towards it, it will give you a pop sound. Okay, then we can take that. That's the hydrogen gas. Next question. Metals reacting with a dilute HCl. Told you, right? Metal react with HCl. They will give a metal salt and the hydrogen gas. They will give a hydrogen gas. Okay. So generally, not HNO3. Generally, they will give the hydrogen gas. Now, copper gas is evolved. They are given like yes. No, copper is less reactive. Copper will not react with the dilute acid. So no gas is evolved. Iron will react with acid, yes, and that's correct. And magnesium, they are like no, magnesium will react with acid, so it will give the gas. Of course, it will produce the gas. And the zinc, of course, it will produce. So, which are the correct options? 2 and 4. 2 and 4 is the right answer. That's option D. Yes, Hannah, of course. Alright, so it is the option D. Okay, it's the option D. Shall I move forward? Can you all nod your head? Nod your head if you... Yes. Okay, got it. Is there anyone sleeping over there? You can raise your hand now if you are sleeping. No hand rises. Okay, thank you. So, metal rod M was dipped in a colored solution. It's a colored solution. After some time, it was observed that metal rod started to dissolve in a solution, and the solution's color is fading. However, a colored precipitate was seen at the bottom of the beaker. Let's look into the first one. Metal is zinc and solution is FeSO4. No. Iron is more reactive than zinc, right? Iron is more reactive than zinc, so reaction won't happen over there. Second one. Copper and what? Yeah, the right answer is zinc, right? No. So, zinc is more reactive than Fe, and FeSO4 is green in color and pale green in color. When we add zinc to it, it turns into colorless. Okay, it turns into colorless, and the color of the solution fades, and this is iron. Iron is like reddish brown in color, right? However, the colored precipitate is seen at the bottom, that is reddish brown in color. Okay. That is reddish that is reddish brown in color. And the copper, when we talk about the copper and the aluminium, copper is less reactive than aluminium, no reaction will happen. And the silver and the copper, silver is less reactive than copper, no reaction again. Fe and zinc, no reaction again. Okay, so Fe is less reactive than zinc. Zinc is more reactive than Fe. Okay, so option A is the right answer. Okay, and the color, I'll give a table to remember. Okay. Okay, so which one of the following is an acidic oxide? They're asking about the acidic oxide, but we have an option like Al2O3 which act as an amphoteric oxide, right? Which is an amphoteric oxide can act as an acidic oxide as well as a basic oxide. They are separately asking about the acidic oxide. That might be the non-metallic oxide. Oh, we already know the non-metallic oxides. Non-metallic oxides are acidic in nature and the metallic oxides are basic in nature. So in the given option, non-metallic oxide is our option C, carbon dioxide. So carbon dioxide is the acidic oxide. Okay, now which of the following oxide of iron would be liberated on prolonged reaction of iron with the steam? We are reacting iron with the steam. Okay, iron, Fe plus H2O. Do you know the reaction? Do you know the reaction? It is Fe3O4 plus hydrogen gas. In order to balance, let's put 4 over here and 2 and 3. Okay, balanced chemical equation is always important. Okay, and you have to write it in a straight line, not like the hills. Okay, okay, straight line. Okay, should be in a straight line. Okay, so the answer is Fe3O4. Fe3O4 is the right answer. Okay, Fe3O4 is the right answer. Which of the following is used in the dissolution of gold? Who can dissolve the gold, guys? It's aqua regia can dissolve the gold, right? It's like concentrated HCl versus concentrated HNO3 in the ratio of 3:1. Okay, if we add 3:1 ratio of hydrochloric acid and the nitric acid, we will get the aqua regia which can dissolve the gold. Okay, and it's called as a royal water. Okay, aqua regia is called as a royal water, as you know. The highly reactive metal like sodium, potassium, magnesium, etc. are extracted by. How are they extracted? Can we extract them by using the reducing agent like a carbon and the aluminium? Can we do that? No. No. The oxides will be having more affinity. They will be having more affinity towards oxygen than any other reducing agents. So they will be reduced by using the electrolytic reduction of the molten chloride. So it is the electrolysis of their molten chloride. Okay. We'll do that by the electrolytic reduction. That is electrolysis of the molten chloride. Okay. Alright. You are just recollecting the points. Okay. And you are not learning the new things. Right. So you are already familiar with these kind of questions. Assertion reason. Okay. Ionic compounds have high melting at the boiling point. Is that correct? Of course. Ionic compounds have high melting at the boiling point due to the strong inter-ionic force of attraction, strong intermolecular force of attraction. That's why they have high melting at the boiling point. Large amount of energy is required to break the strong inter-ionic force of attraction. So assertion is correct. Reason is correct. Reason is the correct explanation for the assertion. Okay, that will fall into the option A. Okay, both of them are correct and reason is the correct explanation for the assertion as well. Now, hydrogen gas is not evolved when most metal react to the nitric acid, exceptional case magnesium and the manganese. Okay, so most of the metals will not give hydrogen gas when react to the nitric acid because nitrogen gas acting as a strong oxidizing agent. Assertion is correct, reason is correct, reason is the correct explanation for the assertion. Next question. Bronze is an alloy of copper and tin, right? Yes, that's correct. Bronze is an alloy of copper and tin. And what about brass? Brass is an alloy of copper and zinc. Okay, you have to remember that. And the reason, alloys are heterogeneous mixture of metals with other metals and non-metals. No. Alloys are the homogeneous mixture. Okay. Can I see the last slide? Okay. So, alloys are the homogeneous mixture of metals with the metals or non-metals. Okay. They are the homogeneous mixture, not a heterogeneous mixture. Okay. Nabila, done? Okay, so it will be like assertion is correct and the reason is false. Okay. What is brass? Brass is an alloy of copper and zinc. Okay, Linda. Copper and zinc. Copper and zinc. Friend, copper and zinc. Okay. And the option C is the right answer. Okay. Ma'am, HNO3 won't ever react with acid. Linda, HNO3 is an acid. Okay. Linda, HNO3 is the acid. HNO3 will not.
It's Srinanda.
Oh, okay, Srinanda. Srinanda, HNO3 is an acid. It will react with the metals. Definitely it will react with the metals, but it will not form hydrogen gas. Okay. Okay. So it will react with the metal, but it will not produce hydrogen gas. We already know that when a metal reacts with an acid, metal plus acid will give you metal salt and the hydrogen gas, right? Metal salt and the hydrogen gas. So in the case of HNO3, they will not give this hydrogen gas because HNO3 is a strong oxidizing agent, oxidizes hydrogen gas into water. So they will give the water instead of the hydrogen gas. Okay, got it? Srinanda, you get it? Okay, so that's HNO3 exceptional case. Okay. Now, in the following reaction, zinc oxide plus zinc and carbon monoxide. Zinc oxide undergoes reduction. That's correct, right? Zinc oxide is undergoing a reduction. Zinc oxide into zinc. Removal of oxygen, reduction. And carbon is a reducing agent that reduces zinc oxide into zinc. So, assertion is correct, reason is correct, and reason is the correct explanation for the assertion. Okay. Yes, that's correct. That's correct. And everyone has given me the right answers. Very good, kids. Very good. I'm really happy. Now, assertion. Assertion A. Zinc oxide is amphoteric in nature. Zinc oxide is amphoteric in nature, right? Yes, they are amphoteric in nature. And zinc oxide reacts with both acids and bases. Yes. So, both of them are correct and reason is the correct explanation for the assertion as well. Now, magnesium chloride is a covalent compound. Magnesium chloride is a good conductor of electricity in the molten state. Magnesium chloride is a ionic compound. They are the ionic compound, not the covalent compound. So assertion is wrong and the reason is correct. And the ionic compounds will conduct electricity in the molten state or the liquid state, not in the solid state. You can expect this question in the exam as well. Why they are not conducting electricity in the solid state? Because of the strong intermolecular force of attraction. In the solid, they will be held together very strongly. They are tightly packed in the solid. And when they are in the molten or the liquid state, the ions are free to move. So they conduct electricity. You can expect that question as well. Okay. Yes. And magnesium chloride is a good conductor of electricity in the molten state. Okay. So what is the answer? Assertion is false and the reason is true. Okay. Assertion is false and the reason is true. Now, metal A which is used in the thermic process. Okay, we are using a metal A which is used in the thermic process. Aluminium, right? Aluminium is the one which we are using in the thermic process. When heated with the oxygen gives oxide B. Okay. Which is amphoteric in nature. Which is amphoteric in nature. That is aluminium oxide, right? When we react aluminium and oxygen together, we will get Al2O3. Al2O3, not to balance 2 and 3 and 4. Okay, Al2O3. Balanced chemical equation. Always write the balanced chemical equation. Okay. So identify A. A is aluminium. What is B? B is aluminium oxide. Aluminium oxide. Write down the reaction of oxide with HCl and NaOH. You have to write. Take a notebook. Quickly take a notebook. Quick. Let me quick. Quickly take a notebook and write the reaction of aluminium oxide with HCl and NaOH. Quick. Okay. Alright, I hope you are writing it down. And if you don't know this, you are done. Okay, amphoteric oxide is really important. You have to study this as well as zinc oxide reaction with HCl and NaOH. It's really important. Okay, so if you are done, give me a thumbs up. Okay, we don't have time to waste, so quickly do it and give me a thumbs up. Write the reaction. Okay, if you don't know this, there is no point that we are running a marathon. Okay, so I'll wait. I can wait. Okay. Yes. Okay, Ephraim, what is the confusion, Ephraim? Okay. Done? Did you get this all the time that you will get? Okay, enough. This is the answer. Okay, aluminium reacted with the HCl and NaOH. Really important one, salt and water. Okay, and you have to write the balanced chemical equation as well. Okay, if you just write AlCl3 and H2O, no one is going to give you the mark. If you write the balanced chemical equation, you will get the full marks. Okay, balanced chemical equation plays an important role, kids. So always balance the chemical equations. Okay. So this is the equation that you have to write. How many of you got it right? You can raise your hand now. How many of you got it right? Only one? One in the class? 2, 3, 4, 5, 6? Literally everyone. Okay. So you have to know this. Okay, you should know this. There is no time to study, so study this right now. Okay. So there's another question, right? In one method of rust prevention, the iron is not coated with anything. We have already know about the galvanization where we will coat a layer of zinc that will prevent the rusting, right? But here there is a one method where we will not coat anything on the iron. Name the method and define it. What is that method, guys? Alloying, right? Alloying. What do you mean by alloying? Alloying. When we mix metals or the non-metals together, it's a homogeneous mixture. In order to prevent the rusting or in order to improve the physical properties of the metals, we will do the alloying. Alloying is the right answer. And alloying of iron is called as stainless steel when we mix chromium and the nickel and a trace amount of carbon as well. Okay, we will be adding a trace amount of carbon as well, and that's called as the alloying. Okay, alloying of iron with the chromium and the nickel and a trace amount of carbon produces stainless steel. Okay, in the exam they might be asking like what are the composition of the stainless steel. You have to give this answer. And which will not corrode, and it is the method where the iron is not coated with anything. The iron is mixed with the chromium and the nickel. Okay. Alloy. Yes. Arish is like, I already know the percentage they are adding, ma'am. Okay. Alright. Mixture of metal and non-metal. Yes, Ephraim. Ephraim is like typing everything and ending with a question mark. Why? Do you have any doubt on that? Alright. So, next one. Give the reaction involved during the extraction of zinc from its ore by roasting of zinc. Okay. It is roasting, right? If it is roasting, what will be that? It will be a sulfide ore, that is ZnS. Okay. Sulfide ore stated in the present, that is roasting. Roasting is in the presence of oxygen. So we have to write ZnO plus SO2. So in order to balance 2 and 2 and how many oxygen? 6 oxygen, 3. Okay. So this is A. Roasting of zinc ore. You should be quick to write the reactions. Okay, sulfide ore. And the second one, calcination. Calcination is the carbonator. Calcination is the carbonator. ZnCO3. Where is the Ca coming from? Okay. So calcination, ZnCO3 in the absence of air. We are heating it. Okay. So in the absence of air, we will get zinc oxide and the carbon dioxide. Okay, so in the sulfide or when we do the roasting, sulfide ore will give the sulfur dioxide. When we do the calcination for the carbonator, they will definitely produce the carbon dioxide. Okay, into the next one, reduction of zinc oxide. We got the zinc oxide, right? We got the zinc oxide. Reduce it by using the carbon. Simple one. Okay, we will get the zinc and the carbon monoxide. Okay, you should know to write the equations. Here we go. This is the answer. Roasting of zinc. Calcination. Okay, quickly take a screenshot. Okay, you should know to write the chemical equations. Okay, chemical reactions are really important. Yes, it is getting decomposed. Of course, it is getting decomposed into zinc oxide and the carbon dioxide. Yes. Okay, the reduction of zinc oxide. Okay, suitable reducing agent, carbon. Okay, done. Can you all give me a high five? If this much is clear for everyone? If this much is clear, give me a high five. Okay, got it. Alright. Into the next question. Of the three metals X, Y and Z, X react with the cold water. Okay, X is reactive with the cold water. Who's reactive with the cold water? Let's take an example of sodium. Okay, sodium will react with the cold water to produce what? NaOH plus hydrogen gas. Okay, plus hydrogen gas. Okay, so let's balance it. Okay, the second one, Y is reactive with the hot water. Who is reactive with the hot water? Magnesium. Magnesium can be reactive with the hot water, right? So magnesium can react with the hot water to produce MgOH twice plus hydrogen gas. Okay, now let's balance it. Put it over here. And the Z is reactive with the steam. They are only reacting with the steam. That means we can have the iron, right? Let's take the example of iron. Fe plus H2O, that's a gas. Okay, and we will get Fe3O. Yes, and it will be balanced. Okay, done. Yes, you can also write zinc and aluminium. Yes, you can. It's your choice. It's your choice. You can do it. You can do it. You can do it. Okay. Yes. Alright, alright. Done? Yes. Okay. Next question. They said us to arrange them. Oh, there's increasing order. Another question. Okay. Arrange them in the increasing order. Simple, right? Increasing order. So iron will be less reactive than Mg, and it will be lesser than sodium. Reactivity series. Okay. Yes. Increasing order as well. Okay, increasing order. They're asking the increasing order. You have to put the less than sign over there. Okay, Fe is less reactive than Mg. Mg is less reactive than sodium. Okay. Yes. Yes, friend, you can also write that. Yes, of course. Arrange the metals zinc, magnesium, aluminium, copper, and Fe in the decreasing order of the reactivity. Do it. In the decreasing order. Okay, in the decreasing order. Do it. Do it. Quick. Who will come first? Who will come first? Magnesium will come first, right? Magnesium in the decreasing order. So magnesium is more reactive than aluminium. Aluminium is more reactive than zinc. Zinc is more reactive than Fe. Fe is more reactive than copper. Okay, you should know the reactivity series is really important. Next, what would you observe when you put some zinc pieces into copper sulfate solution? Zinc into copper sulfate, CuSO4. CuSO4 is blue in color, blue color, right? When zinc is added, zinc is more reactive than copper, displaces copper from its solution. Zinc sulfate is colorless and copper. Okay, zinc sulfate is colorless in nature. Some copper pieces into ferrous sulfate, FeSO4. FeSO4 is green in color. When we add copper into it, no reaction. Ta-da! Because copper is less reactive. Okay. Name a metal which combines with the hydrogen gas. Most reactive metal. The reactive metals will react with the hydrogen gas. Okay. For example, let's take sodium. Okay, let's take sodium. Sodium will react with the hydrogen to form sodium hydride. Sodium hydride is NaH. NaH is sodium hydride. Okay, so let's balance it. Let's take another example of calcium. Okay, calcium will react with hydrogen to form calcium hydride, CaH2. Okay, calcium hydride. This is A, B, and C. Okay, calcium hydride. Name the product formed. Metal hydrides. Okay, metal hydrides will be formed. Okay, metal hydride. Yes, potassium hydride will be formed. Yes, you can write the potassium as well. Okay, potassium hydride. Okay. It's your wish. They are giving the options. You can write whatever you want. Okay. Alright. Next question. The reactivity series, guys. Have to remember the reactivity series. Okay. Reactivity series is pretty important. Okay. Don't go for the exam without studying the reactivity series. Name two metals that start floating after some time when immersed in water and why. Name two metals. Magnesium. Calcium, magnesium and calcium. Okay, magnesium and calcium will float over the surface of the water due to the formation of hydrogen gas, which will stick onto the surface of these metals, and that will act as a life jacket and floats on the surface of the water. Okay, so here we go. Calcium and magnesium are the two metals start floating after some time when we immerse in the water. The bubbles of hydrogen gas which are formed in the reaction stick to the surface of the metal, and thus metal float on the surface of the water. Time, guys, time is running. Explain how mercury is extracted from the sulfide ore. Give equations to support your answer. Mercury is obtained from the ore cinnabar. Okay, how can we do this? This is the reaction. When sulfide ore of mercury, that is cinnabar, right? So it is a sulfide ore. We have to do the roasting in the presence of oxygen and it will get the mercuric oxide. Mercuric oxide is sulfur dioxide, and on further heating it will reduce itself. Okay, so it will be reducing into what is that? Mercury. Okay, it will reduce into mercury and we'll get the oxygen. And this is an example where the least reactive metal. In the exam they might be asking like how to extract the least reactive metal. Okay, you have to explain this process. Heating alone is enough. You don't have to do any other things. Okay, heating alone, just heat it. Okay, just heat it, you will get this. On further heating, mercury can be produced, and this mercury will be in the liquid state. You know that, right? Mercury is the only one metal which is present in the liquid state. Okay. Yes. Got it? Any doubts? Any doubt? That's the question, right? Okay. So you have to remember the equations. Okay, remember the equations. So let's run faster than that. Yes, let's do it. An element Xon reacting with oxygen forms oxide of XO2. Okay, metal X is reacting with oxygen, XO2 is producing. The oxide dissolves in water and turns blue litmus paper into red. Blue into red, guys. Blue into red indicates the acidic nature. The acidic nature of the oxide. Okay. Predict the nature of the element, whether metal or the non-metal. Okay. Metal or non-metal, guys? Non-metal, of course. We already know that non-metallic oxides are acidic in nature. Metallic oxides are basic in nature. Okay, metallic oxides are basic, non-metallic oxides are acidic in nature. XO2 is acidic, that means it is turning blue litmus paper into red. Okay, it should be a non-metal. A solution of copper sulfate was kept in iron pot. Okay, so iron and copper sulfate. Okay. After a few days, the pot is developed with the holes. Of course, holes will be there. How will you account for this? Okay, iron will replace the copper. Okay, FeSO4 and the copper will be produced due to the reaction. Holes can be developed over there due to the corrosion. Okay, due to the corrosion, the iron vessel get corroded and this is the reaction taking place. Okay, alright, because iron is more reactive than copper. Who keeps this, right? How idiot and dumb are they? Yes. Alright, next question. What happens when a metal reacts with a dilute acid? What happens if a metal reacts with a dilute acid? Metal plus acid will give you metallic salt and the hydrogen gas. Okay, and you have to give the example as well. Okay, for example, here we go. Na and HCl, NaCl and the hydrogen gas will be produced. Okay. And how are the less reactive metals extracted? Heating alone is enough. They are least reactive, right? They are the least reactive. Give the example of mercuric sulfide. Okay, mercury sulfide, cinnabar ore of mercury. Okay, explain with the help of an example. The same thing. Metal with the low reactivity series is not reactive. So extracted by heating alone. Heating alone is enough. Okay, for example, mercuric sulfide. We'll get the mercuric oxide. Further heating, we'll get the mercury. Okay, same thing. Just the same thing but different question. Told you, right? They will ask this question. Heating alone is enough for the least reactive metal. Least reactive metal, heating alone is enough. Okay, enough. Done. Okay. So what is meant by reactivity? Series of metals. We are arranging metals in a vertical line according to the decrease in the reactivity of the metals. Okay, reactivity of the metal, this is the decreasing order. We are writing it in a vertical line. That is a reactivity series. Why metals are not equally reactive? Okay, what do you mean by a chemical reaction? How does a chemical reaction taking place? By the loss or the accept or gain of the electron, right? By gaining the electron, by losing the electron, they are undergoing a chemical reaction. And what about the metals? Are they gaining the electron or losing the electron, guys? Are they losing the electron or gaining the electron? Metals. Gaining or losing? Quick answers in the comment box. Are you all sleeping? They are losing the electron, and according to how much easy they are losing. Okay, if they are really happy to lose the electron, they are the most reactive one. Sodium easily remove the electron, right? It can easily remove the electron, so it is the most reactive one. Okay, so according to that, we can arrange the metals in the reactivity series. Arrange the following metals in the decreasing order of the reactivity series. Okay, this is the first answer and the second answer. Okay, and the decreasing order, they are asking for the decreasing order. Just write this. Okay. Okay. Some metals give up their electron more readily than others, and they are more reactive in nature. Okay. Okay. They lose because they mostly form cations. Yes. Metals are generally cations. It forms cations. Okay. All right. All right. Moving ahead. Moving ahead. Are you all keeping up with me? Keeping up, right? Yes or no? Yes. Okay, you don't have any other choice, guys. That's why. In what forms of metal found in nature? Okay, how are they found in nature? They can find in the free state. Okay, least reactive metals they can find in the free state, right? Like gold, they can find in the free state. And they can be also in the combined state like sulfides, carbonates, chlorides, oxide. They can be also in the combined form. With the help of example, show how metal react with oxygen, water and dilute acid. This is a 5-mark question, kids. 5-mark. Color of the pen. 5 mark. Okay, 5 mark. If you want to get the 5 mark, you have to explain everything. How the metals are reacting with the oxygen. So different metals show different reactivity towards oxygen and the water. Know that, right? So you have to explain that. So metals found in the form of free and the combined state. The first one, reaction with the metal and oxygen. If a metal reacts with oxygen, we will get metal oxides. Okay, we will get the let me change the color of the pen and take an example of aluminum or anything that you want and give an example and also show how they are reacting. Active metals, most reactive metals like sodium, potassium, they are all vigorously react with oxygen. We know that when we keep them in open air, they will catch fire, right? They will catch fire. And why they are catching fire, guys? Due to the formation of hydrogen gas. Hydrogen gas is inflammable, right? So a large amount of hydrogen gas will be produced and they will catch fire in the open air. They are highly reactive with the oxygen. And when we talk about the magnesium, aluminum and zinc, when we keep them in the open air, they won't react like that, okay? They won't react vigorously with oxygen. But after a long time, you can see a dull appearance on the surface of these metals. On the surface of the metal, you can see a dull appearance due to the formation of metal oxide, which acts as a protective layer, which will protect them from the further oxidation. Okay, which will protect them from the further oxidation. And coming into the copper, when we heat the copper, no reaction. They will not react with the room temperature. Oxygen, no, they will not react with oxygen at the room temperature. What happens if we heat it? No, again, no reaction. And I am heating this copper for a long time. For hours and hours, now reacted. Okay, and we got the copper oxide, which is black in color. Right? Okay. Now, gold and platinum. Silver, gold, platinum, silver, they will not react with the oxygen. They are least reactive. The least reactive one, they will not react with oxygen. So you should know this, okay? That's why everyone is like gold. Okay. Everyone likes gold. That's again the property. Why we have the ornaments of golds? Because they are least reactive. And if we can make, imagine if we make a necklace out of sodium, what will happen? What will happen? Everything will be gone, right? Our neck will be like in a black in color due to the burst. And gold is least reactive. That's why we are making the ornaments out of it. Of course, okay. Especially aunties and moms like gold just because of this. Alright. Next one, reaction of metal. Sir, can you remove my name tag for a second? Okay. Reaction of metal with water. Again, reactivity differs. Reactivity differs from metals to metal when they react with the water. Okay, the first one, sodium and potassium, calcium, they are all react vigorously. Calcium is less violent. Okay, calcium is less violent with water, but the sodium and the potassium highly react with the cold water. They will highly vigorously, violently react with the cold water, but the calcium is not that violent as sodium. Okay. Okay, and when we talk about the calcium, floating. Remember the floating thing, okay? Due to the sticking of the hydrogen gas above the surface of the calcium, remember that. Coming into the second one, magnesium, they will not react with the what? They will not react with the cold water, but they will react with the hot water. If you just heat them, yes, they will react. And they will form the hydrogen gas, okay. And coming into the aluminum. Aluminum, zinc and iron, they will not react with the cold water, they will not react with the hot water, but when we heat it, they will react. And study the experimental setup, okay? Always study the experimental setup, how to draw the experimental setup. Drawing the experimental setup is really important. They will ask to draw the structure, okay? Draw the apparatus. So just you have to remember that, okay? We have a burner over there and test tube in a horizontal manner, and there will be a cotton plug and a metal sample, and we have to pass the hydrogen through a soap solution and hydrogen gas, okay, the bubbles, you have to show that, okay, and an inverted test tube, downward displacement of gas, okay, you have to remember those things. And that's about this. This is Fe3O4, remember, not Fe2O3, okay. Okay, now reaction of metal with the dilute acid. Reaction of metal with the dilute acid, okay. Now, metals react with the dilute acid, they will form metallic salt and hydrogen gas, as we already know. And sodium, they will all react with the acid. Give an example of anything that you wish, okay. And the thing is, least reactive metal again. Least reactive metal like copper, silver, gold, they will not react with the dilute acid, okay. We'll be taking bath in the fire instead of water when we put the sodium as a necklace, right? Okay. So did you get the questions? Okay, did you got a screenshot of these things? We have 3 slides. I hope you got it. Okay. Here we go. No, we have 4 slides, right? Okay. So next question. Give reason for the following. Oh my God. Time. How am I supposed to complete carbon and its compounds now? Take a deep breath. We can. Okay. So give reason for the following. Gold and platinum are used in jewelry. Gold and platinum is used in the jewelry because they are malleable and ductile and they are least reactive. Okay. Least reactive in nature. Copper cannot displace hydrogen from the dilute acid because copper is less reactive than hydrogen. Okay, so it just falls below the hydrogen in the reactivity series. After the hydrogen, copper is just below that, right? So copper is less reactive than the hydrogen, so it will not displace the hydrogen. Stainless steel does not rust easily because it's an alloy. Stainless steel is an alloy of iron, chromium and nickel. It's an alloy, so it won't corrode. Metals can be given different shapes according to our needs. Malleability and ductility, guys. And you have to form a sentence out of that, okay? I'm just giving the things to write. Just make it a sentence, okay? Alright. No, Amelia. No break. Okay. Zinc does not give hydrogen gas on reduced with HNO3. Okay, when we reduce the zinc with the HNO3, no hydrogen gas will be produced because HNO3 is a strong oxidizing agent, oxidizes hydrogen into water. Okay, so wait, malleability. Yes, ductility and malleability. What do you mean by malleability? Making into thin sheet is malleability, drawing into thin wires is ductility. Okay. Honey, you know that already? Okay, hope you got the slides. Compound X and aluminium are used to join railway track. Okay, which is that compound X? Iron oxide, Fe2O3. Fe2O3 plus aluminium will give you Al2O3 and Fe. This is a highly exothermic process. This is a highly exothermic process. So the iron formed over here. Let's balance it. Okay. So So here we go. This is the balanced chemical equation. And the thing is, this is a highly exothermic process, and the Iron formed over here will be in the liquid state. Okay, that's why we are using them to join the railway track. And name the reaction, thermit reaction. Reaction is called as thermit reaction. Write down the reaction. Here we go. Okay, done. I hope it's done. Their last stress. Yes, Mohammed, you can add that point as well. Okay, here we go. Yes, done, done, done. Now, when a metal X is already answers there. Okay, when a metal X is treated with a cold water, it gives a base Y. Okay, metal X is sodium. When they react with the cold water, they will give a base Y, NaOH. NaOH is the base they will form. Okay, do you know the reaction? This is the reaction. Okay, sodium with the water, they will give you sodium hydroxide and hydrogen gas with the evolution of hydrogen gas. Okay, which will be having the molecular formula of XOH and the molecular mass is 40, of course. Molecular mass is 40, that is 23 for sodium, 16 is for oxygen, and what? Will give you a total of 40. Now, and liberate the gas Z. Z is our hydrogen gas. Identify X, Y, Z and also write the reaction involved. Okay, got it. What are the constituents of solder alloy? Solder alloy. Lead and tin are the constituents of solder. Okay. And which property of solder makes it suitable for the welding electric wires due to the low melting point? They melt easily. Solder will melt easily so that we can join the electric wires together by using this. Okay. Even at the small temperature, they can melt and we can fix the electric wires together. So solder is an alloy which is consisting of lead and tin. What are the composition of the solder alloy? Solder alloy is a lead and tin. Lead and tin, okay? Alright, next question. A metal M is stored under kerosene sodium, okay? So whenever you heard about this kerosene, make sure that's sodium. Okay, it vigorously catches fire, sodium. Okay, if a small piece of this metal X is kept open in the air, they catches fire. The solution of this metal in the water releases great amount of energy, exothermic reaction, and metal catches fire. The solution so formed turns red litmus paper into blue. Red litmus paper into blue, that means it's a basic one. So this metal M is a sodium. Sodium is the metal M. Write the formula of the compound formed when this metal is exposed in the air. The sodium will react with oxygen to form NO2. Okay? Yes. Here we go. Alright. Okay. So, is that the answer for that question? Yeah. So, this is N2O, Na2O, okay? And the sodium is very reactive, that's why we are keeping them in the kerosene. And the sodium chloride and water will be formed when they react with the HCl. Okay, when they react with HCl, they will form NaCl and H2O. NaCl and H2O, okay? No, not NO2, it is Na2O, okay? Sodium plus oxygen will give you Na2O in auto balance. Let's put 2 over here, okay? Na2O, no, yeah, got it. 4, right? 4 Na, okay? Balance the chemical equation. Oh, it's already here, yeah, got it. How many questions are there? What are we gonna do? This guy's time is already up. Carbon, you are done. Okay. Write the steps involved in the extraction of pure metals in the middle of the reactivity series. In the middle of the reactivity series, if it is sulfide ore, we have to do the roasting. If it is a carbonate ore, we have to do the calcination. And we have to follow it by a reduction by using the carbonate ore. Give the example of zinc carbonate and the zinc. They are specifically asking about the carbonate ore. Okay, so you have to do the calcination. And they will undergo reduction by using the suitable reducing agents such as carbon. Okay, carbon is half an hour. Will you complete carbon-itis compound in half an hour? Do you think so? Never. Okay.
I think she meant we are like ready to sit extra 30 minutes for you.
Will you? Half an hour? Oh, a friend's like, ma'am, you can take half an hour more, ma'am. Okay. How is copper extracted from the sulfide ore? How is copper extracted from the sulfide ore? We have to do the roasting, and this is really important. I told you at the beginning, right? At the beginning, this chemical reaction is really important. Okay, so leftover copper sulfide will again react with the copper oxide. Okay, this is cuprous sulfide and the cuprous oxide. Okay, cuprous sulfide and the cuprous oxide. Okay, and we will get the copper to the. I'm not too fast. Aisha's like, who said that? Ephraim said that. Ephraim, you're done now. Okay. So, electrolytic refining of copper, the diagram. Told you, right? Diagrams are really important. This diagram is important, and the steam, reaction of metal with the steam is again important. And another important thing is like, that's in the next chapter. We'll discuss that. Okay. No, yeah, that's the next chapter we'll discuss. The carbon passing with lime water, that experiment is really important, okay? Alright. Show diagrammatically the electron between the atoms of formation of magnesium oxide. You know that, right? Magnesium oxide will be having 2 valence electron, and the oxygen needs that 2 electron, will be having 6 valence electrons in the outermost orbit. Require the 2 electron and will donate. You should write the electronic configuration of magnesium oxygen at the first. Okay, first you have to write the magnesium. Okay, I'll write magnesium. Okay, magnesium is 2, 8 and 2. 12 is the atomic number, and it will lose 2 electron and forms Mg2 plus 2 electrons. And the electronic configuration will be 2 and 8. Oxygen will be like having the electronic configuration of 2 and 6 except the 2 electron, and forms O2 minus with the electronic configuration of 2 and 8. Then magnesium with the 2 valence electron plus oxygen with the 6 valence electron. Oh my god, I'm too fast. Okay, then we will get magnesium Mg2 plus and oxygen 1, 2, 3, 4, 5, 6, 7, 8, and here we go with the 2 minus charge. Okay, here we go. Okay, my tab is blinking. Okay, so it is Mg2, oh, okay, Mg, oh, okay. Did I destroy the tab? Sir, there is some lines on the tab. Okay, I haven't done anything. Okay, I think this tab can hold on. Okay, it's okay, it's okay. Alright, done. Okay, it seems like display constant. There's some lines and dots. Okay, it's okay, it's okay. Oh, done. Okay, clear. Okay. My heart just broke for 1 second, you know. I thought like I destroyed the tab. Okay, what prevents the metals such as magnesium? My god, many heart attacks. Okay, what prevents the metals such as magnesium, aluminum, zinc, and lead from oxidation? At room temperature, it's a slow process. They form some. Okay, now you break everything. No, it's perfectly fine now. Okay. Alright. Alright, they form some protective oxide layer around themselves. They protective layer around themselves, so they will stop them from further oxidation. Okay, here is the answer. And why sodium hydroxide cannot be kept in aluminum container? It will react, right? Sodium hydroxide and the aluminum container, no, it will react and forms this. Okay, the reaction of, write the equation of the reaction that may take place at the same. Okay, aluminum and NaOH. Aluminum and NaOH, aluminum hydroxide and the sodium will be formed, and the aluminum container will corrode and the holes can be seen over there. Okay. Okay, now electronic, oh, everything is green. Okay. So, electronic configuration is given over there. State one physical property distinguish between metals and non-metals. Metals are malleable, non-metals are not malleable. Metals will conduct electricity, generally non-metals will not conduct electricity. Write something, okay? You know, to write the physical properties, right? Am I too rude? Write whatever you want, guys. Okay. You have many physical properties, right? Write anything. Malleability, ductility, okay, brittle, hard, okay, write anything. Okay. What is the nature of the bond found when magnesium reacts with the chlorine? Ionic bond. Write the formula of the compound MgCl2. Okay. MgCl2. Magnesium chloride is MgCl2. That's the formula of the compound. How do you get this? Crisscross method. You know to do that, right? So magnesium, the valence is 2, chlorine is 1. Just do the crisscross, we will get MgCl2. Okay. Now, what is the common between oxygen and the sulfur? Where is oxygen? Oxygen is here and the sulfur is here. Both of them will be having the valency of what? Valency of 2. Okay, both of them have the valency of 2 and the outermost valence electron are again same for them. And draw the electron dot structure for the oxygen molecule. Oxygen, they are not ionic, they are form the covalent bond, right? 1, 2, oxygen forms double bond. Okay. Okay. That's it. 8 electrons the total, okay? That's it. Done? Done? Ma'am, what happened to you? Nothing. Okay. Count 20. Pulsar will be even faster than this. Pratyush. Okay, Pratyush took sulfur powder on a spatula and heated it. Okay, he collected the gas evolved in an inverted test tube over it and shown in the figure. What will be the action of the gas? What will be the action of the gas on dry litmus paper? There is no effect on the dry litmus paper, no color change. Most litmus paper, sulfur dioxide will be formed when this react with oxygen. SO2 will be produced and the sulfur dioxide is what? Sulfur dioxide is, come on, sulfur dioxide is acidic in nature. That will turn blue litmus paper into red. Write the balanced chemical equation for the reaction taking place. How does this gas react with the hydrogen sulfide? Okay, so we have the SO2 and hydrogen sulfide, H2S. Here we go, H2O and the sulfur. Okay, and here we go. This is the balanced chemical equation. Okay, done. Okay. Blue to red. Blue to red. Okay, friend, blue to red. Okay, done. Next question. The student performed the following for experiment. Okay, HCl and Ag. Let's check it out. Okay, HCl and he put silver into it, and FeSO4 and copper and aluminium, Ag and gold. Okay, so based on the above experiment, in which test tube no reaction occurred? In which test tube no reaction occurred? Okay, the first one, Ag and silver. Test tube A. Does the reaction take place in test tube 1? That is silver and HCl. No, silver is less reactive than HCl. So, in which test tube no reaction occurred? Test tube 1. Okay, in the test tube 2, copper and FeSO4. Copper is less reactive than iron, so there is no reaction taking place in the 2 either. Test tube 3, aluminium. Yeah, the reaction will take place. And Au and Ag. No, Au is less reactive than silver, so third test tube, fourth test tube as well. So in 1, 2 and the fourth test tube there is no reaction taking place. Give reason, because reactivity, you should write it. Okay, 1, 3 and 4. Now arrange the given metal sample in the increasing order of the reactivity series. What are the metals that we have? We have aluminum in the increasing order of the reactivity. First one will be the gold, which will less reactive than the silver, which is again less reactive than the copper. Then comes aluminium. Okay. Okay, done. Okay, reactivity series, guys. Okay, carbonate of metal acts as abundant on earth crust and its hydroxide is used in the whitewashing. Okay, calcium hydroxide. Identify the metal. So it might be calcium carbonate and it's abundant in the calcium carbonate. CaCO3 abundant in the earth crust. Identify the metal X, it's calcium. It's calcium, okay. How will you convert this carbonate into its oxide? Calcium carbonate is a carbonator. So we have to heat it in the absence of air. So we will get calcium oxide and the carbon dioxide. Okay. So we got the oxide. Name the process and write its reaction. This is calcination and the equation. Okay. I hope you are getting the questions, right? Are you guys following? Yes, right? Yes. How is the method of extraction of metal high up in the reactivity series different from the metals in the middle of the reactivity series? Highly reactive metals cannot be reduced by using carbon because it has a higher affinity towards oxygen than the carbon. So we cannot reduce it by carbon. Whereas in the case of middle of the reactivity series, first we have to do the calcination. If it is a carbonator, then we have to find the roasting for the sulfide ore. Then we have to reduce it by using the carbon. Okay, so we will get the metal if it is a middle of the reactivity series. Why cannot same process be applied for them? Told you, right? Affinity towards oxygen. Name and explain the process of extraction of sodium. How can we extract the sodium? By doing the electrolytic refining of the chloride. Okay, sodium chloride. Let's take the sodium chloride NaCl, and if you pass the electricity, they are going to split into Na plus and Cl minus. Na plus and Cl minus, and we will be having the two electrodes. One is cathode and one is anode. We have the anode and the cathode. I have that thing, I guess. This is the thing. Okay, we have the anode and the cathode. Anode is positive in nature, cathode is negative in nature. So we have the Na plus is negative, right? Na plus. So NaCl will give you Na plus and the Cl minus. Na, that's a minus, okay. So Na plus is a cation which will move towards cathode, and accept an electron and forms a sodium atom and get deposited on the cathode. How? That's how we will get the pure metal. And what about the chlorine? Chlorine is an anion and which will move towards the positively charged anode, and they will lose 2 electron. Okay, they will lose 2 electron. No, they gain. So the sodium is lose the electron, chlorine is gaining that 2 electron and forms the chlorine gas, which will be liberated. Okay, which will be liberated from the anode. Okay, from the anode it will be liberated. So do you want me to explain that? You have the okay, fine. So NaCl, so cation will be moving towards the cathode and gain the electron and becomes the sodium atom, and which will get deposited on the cathode. Okay, and that's how we extract it. Okay, and what is the other question? Draw the label diagram for the electrolytic refining of copper. This is the electrolytic refining of copper. Again, we will be having the anode and the cathode. Anode will be taken as the impure copper is anode, and the pure copper is taken as the cathode. And when electricity passes, copper will be move towards the pure copper, that is cathode, and the impurities which will be depositing at the bottom of the anode, we can call that as the anode mud. And where is that thing, man? Yeah. Where is that? Here we go. This is the electrolytic refining of the copper diagram. Okay, this is the diagram. You have to remember the diagram. Okay, really important one. This is anode mud. Okay, copper will be liberating into the solution, and equivalent amount of copper will be depositing on the cathode, and impurities will be depositing at the bottom of the anode. That's called as the anode mud. Okay, where we done with this, right?
Yeah.
Okay. Now, write the balanced chemical equation for the following. Mercury oxide is heated. Okay, what will happen when mercury oxide is heated? And we will get the mercury. And the cuprous oxide and cuprous sulfide, we will get the copper. Aluminium is reacted with the manganese dioxide, and we will get the aluminium oxide, Al2O3, and the manganese. And ferric oxide is reduced with the aluminium, we will again get the Al2O3. Zinc carbonate is undergoing calcination, we will get zinc oxide. Okay. Balance the chemical equation, really important one. Okay. Done? Done? Okay. Are you guys alright? Or in the saturated level? No, right? And there's another one. Difference between minerals and the ores. Simple one, right? Elements of the compound which occur naturally in the earth crust is known as the minerals, and ores, which we can profitably and conveniently extract, that's called as the ores. Okay. You can expect this question, but not that important. Okay. I wonder how half of the carbon is really easy, right? There's only esterification reaction. Okay. Alright, so name tag again. So I told you, right? I will give the colors of the compounds. Okay, color of the compound. Just learn this. Okay, quickly take a screenshot of this. Okay. Just don't by heart it. Just try to remember. Okay. Okay, friend. So take down this. Okay. So this is important. Okay. copper nitrate and copper chloride, they are all blue, and copper sulfate is blue in color, and CaCl2 is bluish green in color, FeSO4 pale green in color. Okay, you have to remember this, okay? That's like, ma'am, what are you telling about? Don't by heart it, just learn, okay? Okay. Don't by heart it, but you have to. There's no other way. What should I do? Okay. So, done. Now we are done with the chapter. Okay, done with the chapter. Okay, so if you learn this much from the chapter, it's enough. Okay, enough. If you want to learn more, you can. Okay, but this is enough for this. Okay, done. You don't need ambulance? No, I'm perfectly alright. So, next PPT. Okay, I'll give it 1 minute. Okay, I'll be coming after 1 minute. Wait for me. Okay. Yes, sir. Okay, I'm back. Ta-da! Hello. Let's start the carbon compounds, guys. Are you guys ready for this? 2 minutes. No, 2 minutes. 1 minute was already over. Okay. So let's get started then. Okay. Take a deep breath, guys. Take a deep breath. Come on, take a deep breath. Release. Okay. Don't choke it and die. We have the exam, right? So just breathe out. Okay. Alright. Done. Okay, fresh beginning with the chapter carbon and its compound. You all have the water with you, right? You all have the water, right? Have to drink water, okay? Alright. Here we go with the first question. I hope you're all ready. Okay. Ta-da! Here we go. Where is it? Important topic that we had to learn. Electron dot structure. Okay, you have to remember the electron dot structure for the compounds, especially methane, ethene, ethanol, and enough. Okay, all right, not enough. Just learn few more. Okay, methane, ethene, and ethanol. Really important one. A repeated one. Okay, structural isomer. What do you mean by an isomer? You have to learn it. Homologous series, really important one, and the general formulas as well. And the 4 type of reaction: addition reaction, substitution reaction, oxidation, combustion, and ethanol and the ethanoic acid. Done. Okay, that's it. That's all you have to remember. Can you write? What am I supposed to write? Yes, I will. We have the questions, Safrin. I will. Okay, we have the questions related to that. Identify the unsaturated compound from the following. Unsaturated compounds: alkane, alkene, and alkyne. Alkene and alkyne are the unsaturated compounds. First one is propane. Propane is a saturated hydrocarbon. Propyne. Yes, propene and propyne are the unsaturated hydrocarbon. 2 and 3, which is option D. Option D is the right answer. Good. Which of the following is the correct representation of the electron dot structure of the nitrogen? Nitrogen will be having, this is the formula for nitrogen. They will be having a triple bond between the nitrogen. There is a triple bond between the nitrogen. That's the option D is the right answer. Option D is the right answer. Okay, count the number of electrons. Count the number of electrons and make sure that you give the right one. Okay, it should be 8 for both. Okay, for both it should be 8. Alright. Which of the following does not belong to the same homologous series? Okay, the first one CH4, that's a alkane. C2H6, again an alkane. C3H8, again an alkane. But C4H6, it's an alkyne. Why? And you look at the general formula, it is CnH2n minus 2. In the form of CnH2n minus 2, that means it's an alkyne. So option D is the right answer again. How come everything is option D, guys? Alright. So which of the following statements are usually correct for carbon compounds? They are good conductor of electricity. No. Poor conductor of electricity. Yes. Have strong force of attraction between their molecules. No. Do not have strong force of attraction between the molecule. Yes, that's correct. So it will be option D, 2 and 4. Okay, again D. Alright. The correct structural formula for the butanoic acid. Surprise! Again D. Okay. So this is the correct formula for the butanoic acid. Okay. So count the number of carbon atoms. 1, 2, 3 and 4. Butanoic acid. So carboxyl group over there. COOH. Again. Okay. So structural formula of benzene. That's not D. Okay. Structural formula of benzene is, it is C6H6. So it will be option C. Good. Option C is the right answer. Which of the following are correct structural isomers of butane? Structural isomer. What is structural isomer? Which will be having the same molecular formula but different structural formula. Okay, butane will be having the formula C4H10. Okay, so the first one and the third one will be having the formula C4H10, but they have the different structure. Okay, it's option A. It's option A. Okay, correct option is 1 and 3. Okay, if you have doubt, just count the number of hydrogen in these two. Okay, then you will not get C4H10. If it is C4H10, that will be an isomer. Okay. The formula of 4 organic compounds are given below. Okay, if your 4 organic compounds are given below, this first one is C2H4. Okay, let me note down the structure for that. C2H4 is a ethene. Ethene, okay. The second one is CH3COOH. CH3 COOH. And the second one C2H6. That's our ethane. You should know to draw the structure, okay. Next one is C2H5OH. That's our alcohol, right? C2H5 OH. Okay, these are the structure. This is our A and this is B, this is C and this is D. Now let's look into the options. A and B are unsaturated hydrocarbons. A and B are unsaturated hydrocarbon. No, A is a no, that's incorrect, right? A is saturated. I'm sorry. A is unsaturated. B is saturated, right? What do you mean by saturated? There should be no double bonds or triple bonds between the carbon atoms. We are talking only about the carbon atoms, okay? So here there's a double bond between the carbon and the oxygen atom. We don't count that, okay? So between the carbon atoms, we don't have any double bond. So it's a saturated one. Option B is a saturated, okay? It's a saturated one, not an unsaturated one. So option A will be incorrect. Coming into the option B, C and B are saturated hydrocarbon. B and C are saturated hydrocarbons. That's correct. But looking into the B, it's a derivative, okay? Why B is saturated? Rehan, I told you, right? There should be a double or the triple bond between the carbon atom if it is an unsaturated. Okay, so just look into the bond of the carbon, okay? So not the carbon and the oxygen, don't care about that, okay? So carbon, if there is a double or the triple bond between the carbon atoms, then it will be unsaturated. Now there is no double or the triple bond between the carbon atom, it's a single bond, so it will be a saturated one. But in the second option, it's like a saturated hydrocarbon. Hydrocarbons will be only containing the hydrogen and the carbon atoms in it. But looking into the B option, there we can find the oxygen. Okay, oxygen over there, which is a derivative of hydrocarbon. Okay, we can term that as a hydrocarbon, but usually that's a derivative of hydrocarbon. So option B is again, it will be incorrect. Okay. Now, option C, addition of hydrogen in the presence of catalyst. Okay, addition of hydrogen in the presence of catalyst such as nickel will convert A into C. That's correct, right? Addition reaction will always happen in unsaturated hydrocarbon where they will break the bond between the carbon atoms and two hydrogen will be added up. Yes, addition reaction. That's the correct answer. Okay, option C is the right answer. Addition of hydrogen in the presence of catalyst changes A to C. Okay, option C is the right answer. Okay, why B is wrong? They are asking about the hydrocarbon. Saturated hydrocarbons. Hydrocarbons will be having high carbon and the hydrogen in it. And looking into the option B, where we can find oxygen as well, which is a derivative. We remove the hydrogen and we place the oxygen. So it's a derivative, right? Derivative of hydrocarbon. That's why the option is incorrect. Okay. Next question. You should know the structure of the soap molecule. Soap molecule is really important one. It will be having a hydrophilic head and a hydrophobic tail. Hydrophobic tail and a hydrophilic head. Okay. So, here we go. The option will be, this is an ideal setting of the mycelia formation. Okay. The center one is the oil droplet, right? We have an oil droplet at the center. And the B is the hydrophilic end and C is the hydrophobic tail. So it's the option D again. Okay, option D is the right answer. Okay, A is the oil droplet, B is the hydrophilic. So head will be hydrophilic always. Okay, head will be hydrophilic. Long chain will be hydrophobic, which will not dissolve in water but it will dissolve in the oil. Which of the following represents a saponification reaction? What do you mean by saponification reaction, guys? What is saponification reaction? An alkali into an ester to produce the corresponding acid and alcohol. That is saponification reaction, which is again option D. Okay, everything is option D, guys. So by thinking this, don't make your answer as D in the exam hall. Okay, don't do that. Okay, it won't work, guys. Maybe it will work, but don't take any risk. Okay. Okay, we wish. The answer is D again, guys. Answer is D. Which of the following is not a straight chain? Option D. It have a branch on that. Okay, it has a branch on the option D. So again, option D. Yes. Alright. Now, which of the following is the structural formula of ethine? Ethine. What is ethine? C2H2 is ethine, which will be having a triple bond between them. Okay, ethine. It's option A. Option A, guys. Option A. Okay. Next question. Which of the following are unsaturated hydrocarbon? Unsaturated hydrocarbon will be having double and the triple bond between that. Okay. Second option have a triple bond, and the second last one have a double bond. Okay, 2 and 4. 2 and 4 is the option C. Okay. Okay, done. Ethanol react to the sodium to form two products. Okay, ethanol. Ethanol is CH3CH2OH in the presence of sodium. Removes the hydrogen CH3CH2ONA sodium ethoxide and the hydrogen gas. Option C. Okay. Now, total number of electrons shared in the formation of an ethyne molecule. Ethyne. What is ethyne? Ethyne will be having triple bond and the bonds between the hydrogen atom. So when we draw the electrons 1, 2, 3, 1, 2, 3, 1, 2 and count the number of electrons and you will get it as 3, 9, 11, 12, 13, 14. 10 electrons will be there. Okay, 10 electrons will be there. How did I get 14 over there? 3 and 3, 6, 7, 8, 9 and 10. Okay, 10 electrons. 10 electrons. Okay. And 10 electrons. Okay, got it? Just draw the structure and find the electrons. Okay, don't forget to count the number of electrons for the hydrogen. Okay, don't forget to count these things. Okay, usually you will do that, but don't. Pentane has a molecular formula of C5H10. I'll just tell you a secret of to find the bonds. Okay, how to find the bonds. Okay, I'll just tell you a secret. Before that, let's draw the structure. Okay, 5 carbon atom, it's C5 and H12. Okay, that is 16 covalent bonds, right? We will be having 16 covalent bonds. Okay, now the thing is, you don't have to count all these things. You have a short form for that. Okay, if it is an alkane, just add the number of carbon and the hydrogen atom. Just add the number of hydrogen and the carbon atom and just minus 1. Okay, subtract 1 from that. Okay, so imagine it is C5H12, right? C5H12. Just add the number of carbon and the hydrogen atom. We have 5 carbon atom and the 12 hydrogen atom, which is a total of 17, right? 17 minus 1 will give you 16. Ta-da! That's the total bonds. Okay, you can try it with anything that you want. If it is an alkene, for example, C2H4. Just count the number. Okay, C2H4. That is 4 plus 2 is 6. 6 is the number of covalent bonds in alkene. Okay. Just follow the equation. That's it. Nothing else. Okay. Just follow it. Okay. Just let's take another example of C2H2. That's an alkyne. Just count the number of bonds, number of carbon and the hydrogen atom. It is 4 plus 1. Okay. That is 5. So 5 bonds will be there in this thing. Okay. Let's take it out. 3, 4 and 5 bonds. See? 5 bonds. Okay. Easy, right? Can I write this formula next time? No, don't. Okay, it's a shortcut. Okay, you don't have to draw the structure. You don't have to draw the structure and count it. Don't waste your time. Just do this equation and you will get it. Okay, don't write this. It's not an official equation. Okay, no, don't. Just a simple trick. Okay, just a simple trick to remember. Okay. Okay, I hope you got it. Select the correct answer to the questions. Assertion and reason. Okay, assertion and reason. Esterification is a process in which a sweet smelling agent is produced. Of course, yes. When esters react with the sodium hydroxide and alcohol and the sodium salt of carboxylic acid is obtained. Yes, both of them are correct, but reason is not the correct explanation for the assertion. Okay, both of them are correct, but not the correct explanation for the assertion. Ethane and ethane are unsaturated hydrocarbons. Yes, both contain only carbon, and carbon hydrogen single bonds. No, that's incorrect. Assertion is correct, reason is false. Benzene is a cyclic saturated hydrocarbon. Yes, that's a cyclic unsaturated hydrocarbon, right? Benzene is a unsaturated hydrocarbon. Assertion is wrong. Benzene contain alternative 3 carbon. Do you know the structure of benzene? This is the structure of benzene. Okay, so benzene is containing alternative 3 carbon single bond and the double bonds. That's correct. Reason is correct, but the assertion is false, which will come into the option D. Okay, option D is right answer. Now here we go. In a homologous series of alcohol, the formula of second member is C2H5OH. Yes, that's correct. Third member is C3H7OH. Just add CH2, you will get it. Okay, that's correct. Assertion is correct. Reason, the difference between the molecular mass is 144U. That's 14U. Only 14U, right? So assertion is right, reason is false. Okay. Now, hard water and soft water can be distinguished by using detergent solution. No, not a detergent solution. By using the soap solution, we can determine it. Okay, by using the soap solution, we can distinguish between the hard water and soft water. Soft water will produce the lather, but hard water will not produce the lather due to the formation of scum. Okay, so assertion is wrong, but reason is correct. Okay, assertion is wrong, reason is correct. Okay, again option D. Which of the following hydrocarbons undergo addition reaction? Who are the ones which is undergoing the addition reaction? Who will undergo addition reaction, guys? We have a question like that. We'll discuss it. Okay, we'll discuss it. Rehan, wait. We'll discuss it. Okay. So addition reaction is undergone by unsaturated hydrocarbon. Only unsaturated hydrocarbon will undergo addition reaction. Okay, the first one is C2H6. C2H6 is an alkane. C3H8, again an alkane. C3H6, yes, C3H6 is an alkene. C2H2, yes, C2H2 is an alkyne. And CH4 is an alkane. So, which are the one which is undergoing the addition reaction? The third and the fourth one. Okay, third and the fourth one are the one which is undergoing the addition reaction. Okay, you can take down this. So, who will undergo addition reaction? Only the unsaturated hydrocarbons will undergo the addition reaction. C3H6 and C2H2 are the unsaturated hydrocarbons, so they will undergo the addition reaction. Write the chemical formula of the two constitutive homologous organic compound having the functional group OH. Okay, homologous of organic compounds OH. Okay, just write down. So there is CH3 OH, CH3, CH2 OH. Okay, just add CH3, CH2, CH2 OH. You got it. Okay, next. What happens to the boiling point if the molecular mass increases? If the molecular mass increases, boiling point increases. They require more energy to break all the bonds. Okay, if the molecular mass increases, number of carbon atoms and hydrogen atoms are increasing. That means bonds increases. In order to break all the bonds, we require large amount of energy. So, of course, boiling point will increase. Solubility of organic compounds. Solubility again decreases. Solubility of the compounds decreases. Here we go. This is the answer. Take a screenshot of this. Molecular mass increases, boiling point decreases. Solubility, as the molecular mass increases, solubility decreases. Okay. Done? Okay, done. Here we go. Salt X is formed and the gas is evolved when ethanoic acid reacts with sodium hydrogen carbonate. Okay, salt X is formed and a gas is evolved when ethanoic acid is reacting. Ethanoic acid is our CH3CO. CH3COOH is our ethanoic acid reacting with the sodium hydrogen carbonate NaHCO3 and forms CH3COONA sodium ethanoate or the sodium acetate and carbon dioxide as well as water. Okay, salt X is sodium ethanoate or acetate and gas formed is our carbon dioxide. Name the salt X and the gas evolved. Okay, describe an activity and draw the diagram of the apparatus to prove that evolved gas is one which you have named. Okay, you have to prove it. You cannot be like it's carbon dioxide. No, you have to prove it by doing an experiment. How are you going to prove it? Let's do it. Okay, this is the activity. So we have a clamp over there. Have to clamp test tube. Okay, test tube. This is our test tube. Okay, so test tube will be having what? Our ethanoic acid. Ethanoic acid. Okay, so neat diagram, not like this. Okay, you have to draw a neat diagram. And the thing over here is the sodium bicarbonate or the hydrogen carbonate. Okay, fill it. Okay, and gas evolved. We have to collect the gas, right? A gas will be evolved. We have to pass that through the lime water, guys. Lime water. Another test tube. Another test tube will be there. Another test tube will be filled with the what? Our lime water, and the lime water turns milky. Tada! Okay, we are passing the carbon dioxide side. These bubbles are the carbon dioxide. Okay, and the carbon dioxide will be passed through this tube. Okay, diagram should be neat and labeled. Okay, diagram should be neat and labeled. Got it? Is that right? Yes. Now, when passed carbon dioxide through a freshly prepared lime water, it turns milky due to the formation of insoluble calcium carbonate. Okay, reaction as well. You have to remember the reaction as well. Okay, what happens when we pass this in excess? We will get calcium hydrogen carbonate, which is soluble in water. Okay, so the milkiness disappears. Neat like yours, ma'am? Not like this. Okay, even more neater than this. You cannot write neater than this, you know that, but you don't have that ability as mine, right? I'm a good artist, so I have the abilities. You have to need better, okay? State how would you distinguish between acetic acid and ethanol in the laboratory? Okay, acetic acid and the ethanol. Okay, wait a second. Ethanol is CH3CH2OH, and when we add NaHCO3 or sodium carbonate into ethanol, there is no reaction. Okay, no reaction will take place. Okay, now let's add the CH3COOH is our ethanoic acid. Let's add the same thing. Then you can find the brisk effervescence. If you find the brisk effervescence in the test tube, that's due to the formation of carbon dioxide. Due to the formation of carbon dioxide in the test tube where you have added the ethanoic acid or the acetic acid, you can find the brisk effervescence, guys, brisk effervescence. Then you can identify that as acetic acid. In the alcohol, there will be no reaction. Okay, there will be no reaction in the alcohol at all. Okay, give the equation. Okay, I'll give you the perfect answer. Okay, this is how you have to write it. Okay, so take Na2CO3 and NaCO3 into test tube, mark them as a 1 and 2. In the first test tube, you have to take the acetic acid. In the second test tube, take ethanol and add NaCO3 in both the test tube. If you see the effervescence of carbon dioxide, okay, then you can identify that is an acetic acid, guys, acetic acid. Ethanol will not react with the sodium carbonate or sodium hydrogen carbonate. Done? Done, guys, done? Done. Write the molecular formula of the second and the third member of the homologous series is first member of ethene. Ethene is C2H4 is ethene ENE, and it's a alkene homologous series will be having the formula CnH2n. The first member, okay, the first member is C2H4. The second member will be having 3 carbon atom, C3H6 double CnH2n. Okay, CnH2n just double the number. Then it will be C4H8. Okay, second member and the third member. This is the second member and this will be the third member. Okay, you should know the general formula for that. Okay, alkane is CnH2n plus 2, alkene is CnH2n, and alkyne is CnH2n minus 2. Melina, if you saw that, you'll be like, oh my god, you'll be heart attack. Okay. Okay, done. You're almost at the top. Okay, done. You guys are about to faint, right? Alright. Got it. Okay, that's the answer. Okay. First and second and the third member. Okay. Okay, that is C3H6 and C4H8. You can read this if you want. Okay, the same thing, exactly what I have explained. Okay, Hannes like time dekho, mister. We have 15 minutes. Okay, we are gonna do it. What is homologous series, guys? Homologous series is a family of organic compounds with the same functional group. Okay, if they have same functional group, chemical properties will be same and they differ. Each successive members will be differing by a unit of CH2 and 14 mass unit. Example. I saw the news report saying that board exams are doing open books. Rasim, you heard of fake news. No one is going to do that. Okay, don't expect that. Define the following term, give an example each. Esterification reaction. When we add carboxylic acid and alcohol together in the presence of an acid catalyst, you will get the corresponding salt of the carboxylic acid. No, you will get ester. You will get ester, guys, ester. Esterification reaction. And what about addition reaction? When you add a reagent without removing anything, that is called as addition reaction, and it happens only in the unsaturated hydrocarbon. Let's take the first one, esterification reaction. Let's take the example of ethanoic acid first. CH3COOH plus ethanol. Let's write it from behind. CH3 CH2OH. Okay, so we have to remove the water molecule OH from the alcohol. OH from the carboxylic acid, hydrogen from the alcohol in the presence of an acid catalyst concentrated H2SO4. Okay, so water will be removed. Water will be removed from that. Join the rest of the things together, you will get it. That is CH3, COOCH2, CH3 or C2H5. This is called as an ester or ethyl ethanoate. Ethyl ethanoate. Coming into the addition reaction, we have this ethene. Ethene, we have to add hydrogen. We have to add hydrogen in the presence of nickel, and we will get this without removing anything. Unsaturated turned into saturated. I'll give you the right one. Okay, here we go. Okay, done. Thank you, Hannah. Alright, that's the equation, okay? Esterification reaction, real important one. Esterification plays an important role, okay? Ma'am, before slide, okay. Esterification is really important, okay? Esterification is really important. Have to learn it, okay? Done? Done, guys? Okay. A compound X is formed by the reaction of carboxylic acid and alcohol in the presence of few drops of H2SO4. Okay, carboxylic acid, CH3COOH, and alcohol in the presence. Same thing, okay. If you are not confused, just write this technique, okay. OH from the, okay, if you want to write it directly, you can write it, okay. So, concentrated H2SO4, you will get an ester. Compound X is nothing but our ester, okay, C2H5 ethyl ethanoate plus water, okay, ethyl ethanoate, and H2SO4, and alcohol and oxidation with alkaline KMnO4. Okay, this is our CH3 CH2OH. We are going to do the alkaline KMnO4, alkaline KMnO4, where we are adding oxygen into it. Oxidation reaction, alkaline KMnO4 acts as the oxidizing agent, oxidizes alcohol into carboxylic acid. Okay, gives the same carboxylic acid as used in the above reaction. Give the name and the structure of A. Carboxylic acid is ethanoic acid. Okay, they are asking for the structure as well. Okay, just write down this. So first A is carboxylic acid and B is an alcohol called as ethanoic acid, and X is the compound ethyl ethanoate. Okay, I'll give you the structure, okay. The first one is CH3 COOH. How is the structure? C with the 3 hydrogen atom and a double bond oxygen, O and hydrogen. This is the A, and the B is ethanol, CH3 CH2OH, and that will be CH3 CH2OH. And the final one will be C, that is CH3 COOC2H5. Okay, that will be like CH3. Oh, you have to write the structure, right? Okay, CH3 C double bond O, O then CH2 CH3. Okay, the structure. The structures are really important. Okay, structure. Okay, these are the structure. Also write the reaction. Reaction already written, right? Here we go. This is the reaction, esterification reaction. And this one as well. Okay, done? Done, guys? I was like twinkle, twinkle, little star, how I wonder what you are. Okay. Name the functional group present in the following compounds. Okay, the first one. Can you find a CO over there? That's a ketonic group or the keto group. Okay, ketonic or the keto group. Now the second one, CH3CH2COH. Okay, you can find a carboxyl group. Okay, that's a carboxyl group. And you can find a CHO, that is an aldehyde group. Aldehyde group. Then we have an OH, that is hydroxyl group, right? Functional group present in it. Okay, the first one is a ketone, second one is a carboxylic acid, third one is an aldehyde, fourth one is an alcohol. Okay. No, it's a lie, it's a lie. Everything was a lie. Okay, so keto group. Don't write it as a ketone. Okay, the compound is a ketone and the group is keto group. And COH is an alcoholic group, carboxylic group, carboxyl group. Okay, CH is a aldehyde group, OH, that's a hydroxyl group, and the compound is an alcohol. Okay. Intake of small quantity of methanol can be lethal. Comment. Okay, if we take methanol, okay, you heard about the denatured spirit, right? Denatured spirit. We already know that ethanol is a good solvent. Ethanol is a good solvent. We have to use that. And we have to use that for as a solvent. We will be using that in large amount in the industries, right? In the industry. So what we will do? So the thing is, what was I talking about? So the workers, what these workers will do, they will drink this, right? They will misuse this ethanol. Ethanol is alcohol, so they misuse this by drinking it. So in order to remove the misuse of this thing, they'll add this methanol. Okay, they'll add this methanol to the ethanol, so it will be like denatured spirit. If you drink that, you will die. Okay, that is lethal because methanol, it is dangerous to the liver. When we drink it, this methanol will be oxidized to methanol aldehyde. It will be oxidized into an aldehyde which will coagulate the protoplasm in the cell. Okay, which will coagulate, like when we boil the egg, which will coagulate, right? So likewise, it will coagulate the protoplasm in the cell, and the thing is, when this happens, we will die. Okay. We already drawn it, ma'am. Okay, where is it? This is it, right? This is structure that you want. Who asked it, ma'am? Neeraj. Here we go. This is structure. CH3, COO, C2, CH3. Okay, not a formula, then what do you want?
No, the structural formula. Now we got
this is structural formula, okay? Structural formula. Okay. Now, this is the answer, okay? This is the answer. Okay, done. Take a screenshot, okay? It's not that important, just keep it in mind. Okay. Now, match the following. The first one, an alcohol and the carboxylic acid in the presence of an acid forms an ester, guys. That's an esterification reaction. Definitely it's an esterification reaction. It can be any carboxylic acid, any alcohol, okay? So we are taking the methanol and ethanoic acid, okay? So the formula for this is methyl ethanoate, okay? That is methyl ethanoate, okay? Methyl ethanoate. That's an esterification reaction. Second one, an unsaturated hydrocarbon, addition of hydrogen in the presence of nickel, addition reaction. Third one, chlorine is substituting hydrogen, substitution reaction. And NaOH is adding to an NaOH is a base, adding to an acid, neutralization reaction. Salt and water will be produced, neutralization reaction. Okay. Alright. What are structural isomers? Structural isomers are the compound with the same molecular formula but different structure. Isomers of the first three members of alkane series are not possible. What are the first three members? Let me change the color of the pen. CH3 and C2. Alright. CH3, C2H5, right? C2, 24 and 6, right? C2H6 and C3H6, 7, 8. Okay, these are the first three members. They cannot form what? They cannot form. Why is it called as keto group? It's a keto group. It's a functional group is keto, and that's ketone. Okay, fine. You already answered it.
Yes,
okay, so the first three members will not form isomers because they have only one structure, right? If you just write, they will give only one structure. If they give more than two structure, then it will be structural isomer, right? Yes, that's the answer. Okay. First three members, and they are like, draw the structure of butane. Draw the structure of butane. C4H4 is the where we are starting the structural isomer. Structural isomer will be starting from the butane. Okay, butane. And let's write the structure for the butane. Okay. Will you fill the hydrogen atom, guys? Okay, let's write the skeletal equation. Okay, this is the skeletal equation. Now we can rearrange this as Okay, 2 possible isomers of butane. Okay, write the hydrogen. Okay, write the hydrogen. Fill the hydrogen atoms. Okay, so this, yes, Afshin, yes, of course. So this is the structural isomers of whom? Butane. Butane C4H10. Okay, done. Now, an organic compound A is essential constituent of wine and beer. Ethanol. Okay, ethanol. Okay, not any other alcohol. Ethanol. Oxidation of A yields organic acid B. Okay, that is CH3, CH2OH. Oxidation in the presence of alkaline KMNO4 or potassium dichromate. We are oxidizing it into CH3COOH carboxylic acid. Okay, and we got, this is A and the B. Okay, and name the compound A and B. Write their structural formula. Okay, already written, right? Do you want me to repeat the same things? No, right? Same thing, guys, same thing. We don't have to waste the time. Same things. Okay, alright, write the formula. What happens when A and B reacts together in the presence of a catalyst? I'm not going to tell. This is an esterification reaction. Write the chemical equation. Okay, do whatever you want. It's an esterification reaction. Join this together in the presence of dilute concentrated H2SO4. Then you will get an ester and water. Okay, esterification. Esterification, guys, esterification. Neutral compound A is formed by the reaction of an acid B. Okay, neutral compound A is formed by the reaction of an acid B, which is present in angsting. Okay, which is the acid present in the angsting, guys? Which acid is present in angsting? Formic acid. Formic acid is also called as methanoic acid. Methanoic acid will be having the formula HCOOH. HCOOH is the formic acid. Okay, and alcohol C, which is used in the preparation of tincture of iodine, which is the alcohol prepared in used in the tincture of iodine, it is ethanol. Ethanol. Okay, ethanol. Ethanol, that is CH3, CH2OH. CH3, CH2OH. Now, used in the preparation of tinctures of iodine. And which kind of neutral compound is formed by reacting with them? Concentrated H2SO4. Don't get mistaken. That is not an ethanoic acid. It's methanoic acid. So, ester will be different. Okay. So, that will be an ethyl methanoate. Okay. Here we go. That is HCOO, CH2, CH3. That is an ethyl methanoate plus water. Okay, ethyl methanoate and water. Okay, not ethyl ethanoate. Okay, so you have to think. Okay, you have to think which is the acid present in the angsting. Okay, so you will be ending up with the carboxylic ethanoic acid, and you will get the wrong answer. Okay, if you just do this, all the marks will be lost, and you will be like, yes, I got the right answer, esterification, right? Yes, and you will lose a mark. How many more questions? A lot. Okay, same thing as I have explained. Okay, carbon compound A having melting point 156 Kelvin, boiling point 351 Kelvin with a molecular mass C2H6O. Ethanol, guys, ethanol. Ethanol, soluble in water in all the proportion. Identify A and draw the electron dot structure. I told you, right? Ethanol, electron dot structure. First write the structure for ethanol. This is the structure for the ethanol. Okay. And the electron dot structure. Let's get into the electron dot structure for the carbon. The first carbon will be having 4 electrons. Second carbon will be having again 4 electrons, which is shared by the hydrogen atoms. And how many valence electrons for the hydrogen oxygen, guys? 6 electron. 6 electron require 2. Sorry. Okay, there is no hydrogen. That should be an oxygen. Okay, so we have 6, right? So 1 will be accepted by the hydrogen. Here we go. When you draw the circles, make sure that you include all the electrons. Okay. Done. Okay, electron dot structure. Okay, give the molecular formula of any two homologue of A. Homologue is this is ethanol, right? CH3, CH2, OH is our ethanol. Okay, just continue. Just add CH2 and CH3. You will get it. Okay, just another 2. Okay, this is our thing. The next one is CH3. Add CH2. You will get it right. CH2OH. And second one. CH3, CH2, 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 OH. Ta-da! Okay, how easy, right? Time to go? No, I'm not gonna leave you guys. No, we will complete this and we'll go, okay?
And this is our last chemistry class, no?
Definitely,
Yeah.
you cannot see me again, guys. Do you think you can see me again? Never gonna happen. So, let's continue. Ta-da, you can see my beautiful face for half an hour more, right? You won't see this face again. Of course, we can see in the Instagram, right? Okay, we will come and see you, ma'am. Just stop the class. Okay, no, not gonna stop the class. Okay. What happens when ethanol is burned in air? Ethanol in air, guys. Ethanol in air. So here we go. Ethanol CH3, CH2, OH. Okay. So ethanol, air, we will get the carbon dioxide, water, and what else? Heat and light. Heat and light. And let's balance it. Okay, let's balance it. We have how many carbon atoms? 2 carbon atoms. And now hydrogen atoms are 6. Let's put 3 over there. Now how many hydrogen atoms? 7. Already 1 is there. 3. Okay. Ethanol is heated with excess of concentrated H2SO4. CH3, CH2, OH. Ethanol is heated in the presence of H2SO4. Concentrated H2SO4 act as a dehydrating agent, removes the water molecule. Okay. That is at 443 Kelvin. Okay, 443 Kelvin. That is CH2, CH2. Okay, that will be double bond between them. Okay, or C2H4. Write whatever you want. Okay, C2H4. And the water molecule, of course, water molecule will be removed. A piece of sodium is dropped in ethanol, CH3. Don't mind my handwriting. You already know these things, right? Handwriting. It's worse than anything. I know that. O and A, sodium ethoxide. Okay, sodium ethoxide. And hydrogen gas. Okay, we have to balance it, right? Okay, done. Okay, into the next question. You should know these things, okay? You should know the addition reaction, substitution reaction, combustion, and everything. Okay. A compound A reacts with the sodium metal to form a compound B. Sodium ethanoate, sodium acetate. I'm not going to give the equation again. Evolve a gas, carbon dioxide. I'm sorry, hydrogen gas. Hydrogen gas, right? How did you get the carbon dioxide over there? Okay. So, sodium. They are react with the sodium and forms the hydrogen gas. Burns with the pop some hydrogen gas. Compound A on treatment with the alcohol C. In the presence of an acid, C smelling ester will be formed, guys. Ester, ethyl ethanoate. On addition of NaOH to D gives back B and C. Okay, I will write that. CH3. This is the ester. Okay, this is ester. C2H5. This is our ester ethyl ethanoate. Let's add NaOH into it. We will get back the B. We will get back the B. That is CH3, COO, Na plus what? Plus our CH3, CH2OH. Okay, this was our A is ethanoic acid. Okay, ethanoic acid, and forms. This is sodium acetate. This is B. Okay, sodium acetate is B, and burns with the popsum compound A. Compound A on treatment with the alcohol. Compound A. This is compound A, right? No, compound A is this. This is our compound. Which compound is this, guys? Compound A in treatment with the alcohol. Compound C. Okay, this is compound D. Compound D on treatment with the NaOH gives back B and C. That's it. Okay. Simple one. Write the chemical equations involved. You have to write the chemical equations. What are the chemical equations that you have to write? You have to write the esterification reaction. You have to write the reaction of ethanoic acid with the sodium, and finally this. You have to write 3 equations. Got it? State the reason why. Carbon compound have low melting and the boiling point. Why? Because intermolecular force of attraction is weak. They have a weak intermolecular force of attraction. That's why the melting and the boiling point is really weak. Carbon compounds do not conduct electricity because they doesn't have free electrons or free ions in it. But the exceptional case, graphite. Carbon can form only covalent compounds. Of course, they cannot form the ionic compounds because they cannot lose the electron, they cannot gain the electron due to the high instability. So, they form the covalent compounds as well. Always. Okay. State the reason. Loss of why carbon cannot lose 4 electron to form C4 plus cation. If they lose 4 electron, they require a high energy to lose. Okay, they require a high energy to remove all this 4 electron. That's not possible. If they are gaining 4 electron, they doesn't have enough space to fit all these 4 electrons. Okay, so they form the covalent compound. They share the electron. Okay, the problem also overcome by the sharing of electron. I pray like this kind of question comes in the exam. Me too. Fingers crossed. Okay, you will get it. You already know this concept, right? Do you want me to explain this things again? No. Easy one. Easy peasy. Lemon squeezy. Okay, let's squeeze everything. An acid X and alcohol Y react with each other in the presence of an acid catalyst. Esterification again, guys. Spelling Z. Identify X, Y, and Z. X, ethanoic acid. Y, ethanol. Z, ethyl ethanoate. Write the chemical equation for the reaction involved and name it. Esterification reaction. The substance Z on treatment with the sodium hydroxide produces back the alcohol Y and sodium ethanoate. Saponification reaction. Write the chemical equation for the reaction involved and name it. Saponification reaction. Justify for the name. This is the one which we will use to make the soap. Okay, soap. We are adding the NaOH alkali to the ester. That's how we will make the soap. That's why they have the saponification name. Saponification. How many more questions? We are done. We are done. Okay, the answer for that. Using the preparation of soap, that's why the name saponification. Answer for that question. Okay, let me drink some water. Okay. Okay, done. Take a deep breath, guys. Continue. Name the simplest saturated hydrocarbon. Which might be that? Of course, methane CH4. Draw the electron dot structure. Let's write it in an appropriate manner. Carbon with the 4 valence electrons. Okay, then it will be shared with the hydrogen atoms. And one circle, one circle, one circle, one circle, one big circle, one circle. Okay, draw the circles. Name any two mixture of the carbon compound used as a fuel in daily life of which above mentioned compound CH4 methane is an important component. Natural gas. Natural gas. Our biogas. Everything will be having methane in it, which will be acting as a fuel. Okay. Okay, Neeraj, I will after the question. Okay. In which homologous series of carbon compounds can this compound classify? It's an alkane homologous series. Write the general formula CnH2n+2. Okay. Which type of flame it is produced by burning it? When we burn an saturated hydrocarbon, this is a saturated hydrocarbon, it will give a blue flame. If we burn an unsaturated hydrocarbon, it will give a yellow flame. Okay, unsaturated, yellow. Saturated will give you blue. Unsaturated will give you yellow flame with a soot. Okay, a lot of soot will be there as well. Okay, here we go. Okay, so that done. Okay, almost done. And most of them are esterification reaction, which I am not going to repeat. Again, neutral organic compound X with the molecular formula C2H6O, ethanol, and reacting with acidified K2Cl2O7 gives an organic compound Y, carboxylic acid, oxidized into carboxylic acid, and which is acidic in nature. It's a carboxylic acid, acidic in nature. X reacts with Y on warming in the presence of concentrated H2SO4 sweet smelling compound Z. Esterification reaction. Ester is formed. Ethyl ethanoate. Identify X, Y and Z. X is ethanol. Y is ethanoic acid. Z is ethyl ethanoate. Write the chemical equation for the reaction, for the conversion of X into Y. X into Y, ethanol into ethanoic acid in the presence of K2Cr2O7 oxidation reaction. You have to write the equation. And X into Z, ethanol and ethanoic acid combines together to form ethyl ethanoate, that esterification reaction as well. State the role of acidified K2Cr2O7, important one, oxidizing agent. It's an oxidizing agent. Okay, oxidizing agent. Better than doctor's handwriting. It's oxidizing agent. H2SO4 is an acid catalyst. Okay, acid catalyst. Okay. You can understand the handwriting, right? Oxidizing agent and the acid catalyst in the esterification reaction. But in the case of ethanol into ethene, H2SO4 acts as the dehydrating agent. Okay. Ethanol into ethene, that's a dehydrating agent. But here it is an acid catalyst as well as a dehydrating agent because we are removing the water, right? Okay. Name the reaction which occurs when Z reacts with an alkali. Okay. Z is our ethyl ethanoate, reacts with NaOH. We will get back this carboxylic acid, salt of sodium, salt of carboxylic acid, and the ethanol, saponification reaction. Saponification reaction. Carry out the following conversion stating the condition for each. Ethanol into ethane. Okay, let's do it. Ethanol is CH3, CH2OH. Okay, we have to convert into ethane. Then we have to remove the hydrogen. Okay, so we have to write concentrated H2SO4 in the in 443 Kelvin, guys. 443 Kelvin. So we have to remove the water molecule and become CH2 plus water. Okay, that is, you have to also reaction conditions, taking the conditions. Okay, reaction conditions should be there. Ethane into ethane. Okay, ethane. Ethane into ethane. Ethane is this. Okay, what we have to add? Hydrogen in the presence of nickel. Hydrogen H2 in the presence of nickel. Okay, we can write H2 over there. Okay, instead of writing above the arrow mark, just write it as plus H2. That will be better. Okay, plus H2O and above the arrow mark nickel and 473 Kelvin. Okay. And we will get only one product. Okay. There is no additional product in over here. When reagent completely adds up to a compound without removing anything, that's an additional reaction. Okay. Now, ethane into chloroethane. Ethane. What is ethane? Okay. So, 1 minute. Ethane into chloroethane. Ethane CH3 C2H5. Let's write it as C2H5. Okay. Ethane. Okay, ethane into chloroethane. Man, remember the question when I said yesterday, Rohan will say option or correct if you're writing. Linda? Which question, Linda? Yeah, the thing is just I have explained right there, right? I have told you, right? That is correct, but C will be better one. Okay, the better one is option C rather than choosing the B because we are talking about the hydrocarbons, that's a derivative. Okay, that can be correct, but more appropriate will be the option C. Okay, now we have to add the chlorine. Okay, we have to add the chlorine. That is Cl2 in the presence of sunlight. Okay, can you see that thing? Where should I write this? Shall I rub this thing? Okay, I'm gonna rub this, okay? Okay, so ethane is CH HCl, okay? Now, ethanol into ethanoic acid. Same thing, K2Cr2O7 in the presence of K2Cr2O7, you will get the ethanoic acid oxidation reaction, ethanoic acid and the ethanol will give you ethyl ethanoate. This two reaction I have written multiple times, guys, multiple times. So, not gonna repeat. In the presence of sunlight. Sunlight. Okay, in the presence of sunlight. I can write it better, you know. I thought like you already know these things, that's why.
promise.
Alright, that's just she's alright. Alright, that was a sunlight. That was supposed to be a sunlight. Alright, next question. Name the compound formed when ethanol is heated with the 443 Kelvin in the presence of H2SO4. That is thus ethane. Okay. Water is removed, right? Water is removed. Draw the electron dot structure for this. I hope everyone is following me. Electron dot structure for that. State the role of H2SO4 dehydrating agent. Okay, removing the water molecule, dehydrating agent. Okay, what is hydrogenation? Addition of hydrogen in the presence of catalyst. Hydrogenation. Explain it with the help of a chemical equation. That's the same thing, right? Okay. Plus hydrogen. Bear with my handwriting. Okay, just one more day, right? Few more minutes. Okay, few more minutes. And I won't be coming again in your life. I'm leaving. Alright. And the hydrogen, don't overreact. Okay, just do the reaction. Okay. Explain the help of reaction. State the role of reaction in the industry. Okay. We have what? Vegetable oil. Vegetable oil. Let's add hydrogen into it. In the presence of nickel, we will get the vanaspati ghee. That's not a she, it's ghee. Okay, ghee. Okay, now my friend will be like, ma'am, what is this? Okay, done? Done? Okay. Few more minutes ago. Draw the structure of ethanoic acid. You should draw. Name the compound formed when ethanol is heated with ethanoic acid in the presence of concentrated H2SO4. Ethyl ethanoate. Complete the following equations. Complete it by yourself. So we have done it multiple times, right? Same questions, guys. Same questions. Okay, nothing different. Okay, it's all same. Okay. Return. Okay, few more. Few more questions. Okay. Soaps and detergents. Both are type of salts. Okay, both types of salt. State the difference between them two. Okay, what is the difference between the soap and detergent? Soap is the sodium or the potassium salt of long chain carboxylic acid, where detergent is the carboxylic acid, ammonium or the sulfonate salt. That's it. Okay. Difference. Most of the time they won't ask this, but if they ask, you cannot like haven't studied this now. Okay, you should know this. Okay. Write the mechanism of cleansing action of soap. Okay, so soap molecule will be having a head and the tail. Head is hydrophilic and it is polar in nature. Okay, it's ionic. And this is non-polar hydrophobic tail, which is afraid.
It's okay, but nothing.
Okay. Okay. Alright, cool down. Did you heard that sound, guys? That is chair, okay? Always. Chair, okay, chair. Okay. God. Okay, it was chair, guys. Don't make mistake that. Hydrophobic tail and the hydrophilic head. And when we wash a cloth with a soap, they will form a structure like a micelle where this head will be protruding outside because they are hating oil. Where this hydrophobic thing loves the oil and soluble in the oil, so they will make a spherical ionic structure that's called as a micelle. Micelle will be formed. You know this, right? So when we agitate the cloth or the grease, and everything will be going ahead with the soap molecule. Okay? Alright. Alright, that is the cleansing action of soap. Okay? I hope you know this. Now, what was the other question? Why does soap not form lather with hot water? Why? Because hard water will be having what? Magnesium and the calcium ions in it. That is Mg2 plus and the Ca2 plus ion. For example, let's take this soap as the RCOONA. Okay, this is our soap. Let's consider that R as the long chain. Okay, long hydrocarbon part as the R. Okay. Now let's add Mg2 plus, which is from the hard water. Okay, so here we go. We will get RCOO twice. Wait a second. That was correct, right?
Yeah.
And Mg plus Na2 plus. Okay. That's it. Okay. Now, if you want to take about the calcium, what about the calcium, guys? RCOO.
It's a chair. Guys, it's the chair. Trust me.
Okay. But it's literally smelling, okay?
Shut up, man.
Alright, guys. Just joking, okay? RCOO twice and Ca and Na plus. These things are insoluble and these things are called scum. Okay, this is scum. Someone asked earlier, like, what is scum?
Look, every class we hear there is the chair we do.
Okay. But it is literally smelling, guys.
Shut up.
My god, it's a YouTube live, right?
Yeah.
Act nice. It's a YouTube live, guys. Okay. Alright, what was the thing that I was talking about? Scum. In the earlier thing, someone asked about the scum. This is scum, okay? RCO, Ca and Mg. That is scum which is insoluble in the water, okay? That is why they are not forming scum. That's why they are not forming lather in the hard water. Disadvantage of the detergent of the soap. Soaps are biodegradable. Okay, soaps are biodegradable, but detergents are not that biodegradable. It will harm the nature. And detergents contain too much alkali, which damages the clothes. Okay, done. Give a chemical test to distinguish between the saturated and unsaturated hydrocarbon. Guys, when I see the comment box, I keep on getting laughter. Okay, you know that I cannot control my laughing. You know that, right? If I start it again, it will be like, you cannot leave the class. Okay, just 10 more minutes left. Just hold on, okay? Otherwise, okay. So it is bromine water test. Remember bromine water test? Bromine water test, guys. Bromine water test. Okay, so bromine water test is a kind of like addition reaction. We already know that addition reaction will only happen in the unsaturated hydrocarbon. So it will decolorize the bromine. Bromine water is like a reddish orange in color. Bromine water is reddish orange in color. And the unsaturated hydrocarbon will decolorize the bromine water, whereas the saturated hydrocarbon will not react to the bromine and they will not discolorize the bromine water. Okay, here we go. That's the answer. Bromine water test. Okay, I have already told this in the class itself. And ethane in the air. That is the second question, right? Name the product formed ethane burns in air, carbon dioxide and the water. Write the balanced chemical equation and the type of energy liberated, heat energy and the light energy. Why the reaction between methane and the chlorine? Chlorine is substituting one of the hydrogen from methane and that is substitution reaction in the presence of the sunlight. Usually the saturated hydrocarbons are not that reactive. Okay, so if we just heat it in presence of sunlight, okay, we are not heating. If we are just put that in the sunlight, they will react, okay, but it will be really slow, okay. All the chlorine comes, it cannot be like all the chlorine all of a sudden comes and displaces all the hydrogen atom. It cannot be like that. It's a stepwise manner, okay. And at the end, by the removal of all the hydrogen gas, by the stepwise manner, we will get the final one as tetrachloride, okay. That's it. Okay. I will, Linda. Good memories, right? Memories, bring back memories, bring back Write the chemical formula and name of the compound which is active ingredient in the alcoholic drinks. Okay, ethanol. Lists two uses. It actively used as a solvent and in the beverages, alcoholic drinks and tincture of iodine in tonics, cough syrup and as anti-freezing agent. And also, have you heard about power alcohol? Power alcohol mixed with the petrol and used as a fuel. Power alcohol. Okay, use the equation. And the reaction with the sodium ethoxide will be formed. Hot concentrated sulfuric acid removes the water molecule and forms ethene. Okay, done. Almost done. Almost there. Almost there. Okay, the answer for that. And for that, okay? Ma'am, you know so much about alcohols. It's all coincidence, guys. Okay? Coincidence. You are officially disqualified from the marathon. It took a long time, right? Write the structural form of all the isomers of hexane. Important. Okay? Hexane is our... Okay. That's a 5. 3, 4, 5 and 6. Okay, 6 carbon atoms. This is our hexane, right? Fill it with the hydrogen atom. This will be the first isomer. Okay, first isomer, 6 isomers. First one and the second one. So I'm gonna write only the skeletal structure. Okay, 5, and let's write 1 carbon over here. So I'm gonna write the skeletal. Okay, fill the hydrogen atom. If you just leave like this, they are not gonna give the mark. Okay, they are not gonna give the mark. So just fill it with the hydrogen. And the third one, guys, third one. Okay, 1, 2, 3 and 4. Let's write 5 and 6 over there. Okay, yeah, again an isomer of the isomer, right? Okay, okay. So
really scared to turn.
I'm
stuck here, guys.
Mahima is like sitting still. You know, she's not moving because she cannot hold on with the sound. She cannot hold it, guys. She cannot. Okay, next one. We can write like this, right? 3, 4, 5 and 6. Okay. Why, ma'am?
You continue, ma'am.
It's all the sound. It's all into the sound. Okay. You could have gone outside and do it. Live, guys, live. Okay. So 1, 2, 3 and 4. Okay. 4 isomers. Okay, 4 isomers of hexane. Fill it with the hydrogen atoms. Okay. Name oxidizing agent that you use to convert the alcohol into acid. Acidified potassium permanganate, alkaline KMNO4. Distinguish between ethanol and ethanoic on the basis of litmus paper. Litmus paper will turn blue into red in ethanoic acid, but in ethanol there is no color change. Blue litmus paper remains blue, red litmus paper remains red in the alcohol because it's neutral. Reaction with the sodium hydrogen carbonate. When we drop sodium hydrogen carbonate in ethanoic acid, carbon dioxide will be formed and sodium ethanoate or the sodium acetate. When we drop the sodium hydrogen carbonate in alcohol, there is no reaction. No reaction, okay? No carbon dioxide, not at all a reaction, okay? Distinguish between that. An organic compound acts as a liquid which often freezes during the winter time in cold countries. Ethanoic acid. On warming it with ethanol in the presence of few drops of concentrated H2SO4, compound Y, ethyl ethanoate. Identify X and Y. X is ethanoic acid and Y is ethyl ethanoate. Write the chemical equation involved. You will write it. Saturated organic compound A belongs to the homologous series of alcohols. On heating A with the concentrated sulfuric acid at 443 Kelvin, it forms an unsaturated compound B. Okay, that's ethene with the molecular mass 28 U. The compound B on addition of 1 mole of hydrogen, addition reaction, ethene, add hydrogen into it, we will get ethane. Okay, in the presence of nickel changes to saturated hydrocarbon. ABC. A is nothing but ethanol. A is ethanol. Okay, A is ethanol. B is ethene. And we are converting that to saturated hydrocarbon C, that is ethane. Okay, write the chemical equation involved. Okay, what happens when C undergoes combustion? Okay, you have to write it. Ethane undergoing combustion. Ethane, oxygen, carbon dioxide, water, and balance it. Stage 1 industrial application of hydrogenation reaction, conversion of ghee oil, vegetable oil into ghee. Name the product formed when compound A reacts with the sodium. Sodium ethoxide and the hydrogenic acid. There's an essay over there. That's a comprehensive not the competency based. What kind of question is that, ma'am?
Passage-based.
Passage-based question. Okay, that's the passage. You don't have to write it. Okay, what's the difference in the molecular mass of two consecutive members? Consecutive members, not constitutive. Consecutive members. That is CH2. Okay, which of the following organic compound belongs to the same homologous series? CH4, it's an alkane. C4H6. C4H6 is again an alkane. C3H6. C3H6 is an alkyne. C5H10 again an alkyne. Okay, first two are alkanes. Second, the third and the fourth are alkyne. Okay, no, this is alkene. This is alkyne. These two are alkane. Okay, done. Okay, yeah, that's correct. See this alkane. C4H6 is an alkyne, C3H6 is an alkene, and this is an alkyne. These two are the right ones, okay? C4H6 and C5H8. Which two of the following organic compounds belong to the same homologous series, C4H6 and C5H8? Write the next homologous series. Okay, next homologous series, C2H4 belongs to the alkene homologous series. So next one will be C3H6. C4H6 is an alkyne homologous series that belongs to the general formula CnH2 and minus 2. So that is C5H8. Okay, done. You're actually drunk. No, I'm not. And it's over. It's over? No. The answer for that. Is it over? Fingers crossed. Yes, it's over, guys. It's finally over. And I have a card for you, okay? So, thank you so much for being here with me all the time. And all the best for the exam, okay? Okay. Wish you all the success in your future. All the best. And thank you so much. Okay, all the best. I won't be seeing you guys again. So, we'll miss you. Yeah, I'll miss you too again. Alright, thank you so much. And good luck for the exam. Okay, do well. If you're writing your exam, just remember my face and you will forget everything. Okay, so don't do that. So, write exam in a proper way. Just take your time. Read the question properly. And make sure that you have the right answer in the answer script. Okay, and write the balanced chemical equations as well. Good luck, guys. And I love you all. Okay. All the best.